Paleontologizing.
Hi, Mark.
Hi.
Are you paleontologying?
It's called paleontologizing. Ah!
There was a partial skull, I think, from the 1970s, 1940, but it wasn't very good. And then in the 2000s, they started to find one or two nice, complete skulls of Thescelosaurus. And they found that it looked really quite different from Hypsilophodon. It had like a long, pointy snout and various other features that mark it out as being quite distinct. So a number of years ago, let's say 3 years ago, actually, no, it was pre-COVID, so it would have been about 2019 probably. We climbed into the pit and we got out our saw and we sawed the head off the Thescelosaurus. And I tell the kids, as is traditional in Britain, I put it on public display.
On a pike,
Yeah, on a spike, to serve as a warning for other dinosaurs. And we got a cast from a Trebold of a nice reconstruction of the real skull and stuck it on there. And
I'll go this side. Cool, thank you.
Right. Thanks so much for stopping by.
Thanks so much. I was going to check. Oh yeah, this is what I was going to do. Would you like my beaver?
Sure.
It's Becky's beaver.
That's lovely. Thank you very much. I
Do you want a
appreciate
beaver?
that.
Oh, yes, please. There you go. There's 1,000 of them. I'm giving out 1,000 beavers. Yeah. Cool, thank you.
Thank you so much for stopping by. I appreciate it. Yeah.
Awesome.
I'll see you around.
Nice to meet you.
Yeah, you too.
Yeah.
What do you stream, by the way? You do music?
I do DJ.
DJ.
And then I've also started an IRL stream.
Very
so
cool.
this is the DJ stream, and then
Nice.
the IRL one is the same name, but with IRL on there.
Nice. Very nice.
Yeah, cool. So yeah, cool.
Great to
I'll be
meet
in
you. I'll have to
chat.
check you out.
Yeah.
Take that geology course, absolutely. Once you start to see things from a geological perspective, it's like that could be life-changing for a lot of people. It's great. So take that course. Yeah. And 1/4 of the ice train. There you go, Jody Fish. Yeah. Yeah.
Eventually we'll work out exactly where the
Yeah.
tie down.
And 32 degrees Celsius. That's
Dug up in 87.
really.
Old Stegosaur.
Wow. Yeah.
Right on the
Amazing.
hips.
And look at those like blood vessel grooves, probably for
Compare
keratin.
that to Apex. Plates are totally different.
Interesting.
And this is one from heading down to the shoulders.
So this would be like from the hips or that area, right?
Yeah, this
Basically,
right on the
it's-
hips. This is getting down more of the shoulder.
Yeah, yeah.
You see it start developing a split base. There, they get real split and smaller as you get to the neck.
Very cool.
But I remember digging both of these up.
Yeah.
That one, the jacket was probably 600 pounds.
Wow.
Huge jacket. We had a helicopter to get them out. But that jacket, preserved this intact.
Well, that is the beauty.
Can we flip it without destroying it?
Oh my goodness. Well, this is the beauty of the resins and to make it, it's heavy, but not like heavy that we can
But you
take
picture that
it.
covered with horn.
Yeah.
The horn coming out,
Then I walked around to the other side of the boulder, and there's a cobble sitting there. I picked up that rock and I turned it over.
It was the skull, isn't it? Was it the skull? I promise I haven't seen this before. Was it the skull there?
Side of the boulder, and there's a cobble sitting there. I picked up that rock and I turned it over, and there's this dinosaur skull staring back.
Bingo.
So if you have the skull on one side.
How close can we get? Yeah. Oftentimes the headline is, "New relative of T-Rex discovered." It's like, just let this dinosaur be its own thing. You don't always have to bring T-Rex into it, you know? But this is the thing, is that people are really familiar with this dinosaur, and that helps drive clicks and everything, and it's just a little frustrating that everything has to be all about T-Rex.
Oh, the old buggy fern pen. The old buggy fern pen. I was born in 78 in the old pen.
Like children we'd sing in the foggy fern bend. How I wish I was in foggy fern bend now.
Oh, don't we?
178 degrees. How I wish it was a foggy fern pen. With the temperature crawl up on my leg. You drinking enough water?
We've got Ethan on vocals here.
Need more fog. Fog bell.
Fog does sound really good right now.
Celtic hour. Oh yeah.
Check out this turtle. The Hell Creek Formation is just chock full of turtles. There's so many. I think it might be like peak turtle diversity over Earth history. There's like 22 species of turtles in the Hell Creek Formation. And this, I think, is one of only one or two that actually goes extinct at the same time as the dinosaurs. This game is set just before the dinosaur extinction, 66 million years ago. The big asteroid hits Earth. Almost none of the turtles die out except for one. I think it's this one, the biggest one. This is Basilemes, whose name means king turtle. So quickly on its feet, it's like pieces of a puzzle, but I love to try and solve. So much fun to think about how a species has evolved, and all the kids who want to see them lining up at all museum. I am a paleontologist. That's who I am, that's who I am, that's who I am. I am a paleontologist. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am.
Wait, who are you? Oh, okay. and then it's what is it, Katy Perry? Yes, we're sending you to Hollywood. And Luke Bryan, yes. And then Lionel Richie, yes. You're gone.
But giant anteaters are not from Africa. They don't exist there. And so, you know, in a film with all kinds of, you know, talking, singing animals, it just completely ruins my, you know, immersion in the film. My suspension of disbelief shattered when they start having animals that aren't even from that continent. For shame.
This is the sound.
My immersion, says Claire Burr. I know, right? Oh, those, you know, can you believe it? Can you believe it, chat? Egrets. I've had a few. Catching fishes down by the bayou.
Triassic, but also in the 21st century.
Yep. Plate tectonics never stops.
It never stops. So,
I promise I did not pre-watch this. Somebody clip that. He's right. Plate tectonics never stops. Plate tectonics, you know? Yeah. There appeared in the Ornithischian dynasty some of the more bizarre creatures capricious nature ever designed. Stegosaurus was a ponderous, low-slung, humpbacked beast, 10 tons in weight, 20 feet in length, which plodded awkwardly along on extraordinarily mismatched legs, carrying his inconsequential pointed head close to the ground, bowed down by an apparently useless parapet of heavy triangular plates running almost the entire length of his spine. That's like completely wrong. Shoot. Where do I even start?
Yeah, I don't know if I have the personality to be a governor.
No?
I do love to lie.
How do you feel about corruption?
You into it? And DCI Bank says, so if bats are birds, bats are not birds. No, bats are mammals. They're not birds. Yeah, bats are related to, oh goodness, what are bats related to mammal-wise? I think we're still kind of figuring that out. But bats might be kind of close to like rodents or carnivorans. I think there's still debate about that, but bats are definitely not birds. Thank you, Dorkalotl. GI Rex, what if you bought it and you can't buy this? No, this is the property of the people of the United States. You can't, this is not up for sale, you know? So what if you were to buy it and donate it to the NHM in London? What if I were to go to your country and, you know, buy the Queen and put her in a museum? Yeah, bring her to the American Museum of Natural History in New York. You know, you just can't do that kind of thing. That's not how it works. And, go put pants on. I do have pants on. Say a G soldier. Also hunting looks chill, says my shout. I don't know if that's quite the right adjective to use.
So chill. I just like dig rocks all day and eat, dude. It's just like,
It's only like 106 degrees out right now.
Yeah, dude. I mean, just come out here, dude, and just like put your feet up, just chill out, and just get bones all day, dude. It's just like not that bad, dude.
They look like. What is this? From Joshua Sweet. Wait, what? Oh no. A side-by-side of me and, is this Chris Pratt? Oh my goodness. I will choose to take that as a compliment. Thank you. Let's continue. And it might take a minute until it goes, because YouTube is having some real trouble right now. So, yeah. We'll wait for it. Come on, you can do it, YouTube. You can do it. Their sound still isn't working. Oh boy, come on, YouTube.
If we're going to get a little more fancy, we could talk about two main types.
As scientists, this is really important, so I'm glad that you're trying to ask this question. This is fundamental, foundational stuff. If you don't understand this, you don't understand biology. So thank you for giving me an opportunity to talk about it, because there's other people in the chat for whom this will be new information too. And I wish this sort of thing were taught in schools more.
And weigh as much as 145 metric.
Yeah, rawr, blue whales, they're big. They're essentially weightless because they live in the ocean, you know? Whales cheat.
Tons, more than twice as heavy as the most.
Incorrect. Oh, wait, what? I'm sorry, what? No. No. I've never seen this before. That's insane. What? Oh. Yeah, look at all this loose fur. Whoa. Minnie, careful. She just straight up fell off the desk. Mini pod. Now, if you're born with those, and these fish do not lay eggs, they're born live. Yeah, like he said, poor mom. How does that happen? Well, shoot. The babies will actually use the saw to cut their way out of them. I'm totally kidding. That's not, they do not do that. Here, watch.
Thought is poor mom, you know, how does that happen? It's really cool in that the rostrum is very flexible when they come out. But the teeth are needle sharp. but they're almost completely enclosed in a gelatinous material that sheaths the teeth so they don't damage the mom. And then,
how cool is that? They've got like a temporary sheath over it that that's just for while they're being.
How many new?
They were terrible lizards, don't you know?
It depends on who you ask. I'm actually working on a project about this right now for publication. I'd say there's about 1,000, but there's been over 2,000 different names that have been published, but a lot of those aren't valid.
Right.
Yeah.
Sure.
Yeah. So, but yeah, I'm working on that exact question right now.
So you're not, like, if you just were to choose one right off the top of your head, what would you go to?
Oh shoot.
Here, you got 5 seconds.
Let's say Triceratops.
Oh my god, I've never even heard of that one.
Well, it's because it's new, yeah.
Oh.
So in 2020, it was just published. It's from the Hell Creek Formation. It's an alverosaur. So it's one of these little guys. They're little theropods. They've got long, stilty legs, and they've got super weird, short arms. They've got one, like a thumb claw, and that's it, basically, on their arms.
And so super small because there is basically no use for them, or just
It seems to be the opposite. Like, the arms are super robust. They seem really muscular.
like a T-Rex.
Kind of, but like T-Rex does have kind of reduced arms. These guys are like, their arms are super short but super thick and super strong. And it seems like maybe they were using those claws for digging open like rotting logs and stuff to get at the insects and stuff.
Scratching their back.
It's way too short for that. Like they could.
We'll scratch in here.
And maybe they could just about scratch there, but that's it. Like,
push-ups.
I should show you a picture of one of these guys. Maybe I can find it real quick.
Oh my gosh.
But they're really strange.
Not for push-ups, like really teeny push-ups.
Yeah, they would be. I mean, you're gonna. Here, I'll show you Mononychus, which is basically the same thing, but there's better illustrations of it.
I should start reading up on the newer books because I feel like I'm falling behind on the new stuff.
Yeah. Trying to find you a good picture. Let's see. Yeah, like that's a pretty good one. That's a plastic model.
Okay.
So they had feathers.
All right. Look at that.
Yeah, and they've just got these super short arms that are really, really thick, and they've got Mononychus means one claw because they've got one big claw.
That makes sense.
Sometimes they have two little vestigial ones next to it, but let's try to find another one.
And so what do you like about it? Just because it has weird arms?
I'm one of the authors on the paper. So it's the first dinosaur, first new dinosaur where I'm an author on the paper. So yeah, yeah.
Well, that's super fun. Did you get to help choose the name?
I didn't actually. My crew chief came up with that. The name Triceratops, get this, it means Captain Hook.
Oh my god.
Triceratops prairiensis is the full name, so Captain Hook of the Prairie. So Triceratops.
Triceratops. Oh
Yeah.
my goodness.
So it's related to Mononychus. It's basically identical to the dinosaur I just showed you.
Wow. And what kind of line of theropod were you related to again? Like a.
So they're alverosaurs are related to. Shoot, I think they're still kind of a mystery. They might be close to ostrich dinosaurs, the ornithomimids. Yeah.
Yeah, that's what like Rebecca's.
Yeah, Arkansaurus, one that she named. Yeah. Yeah, they're cool. I also really like ceratopsians, so I've dug up a lot of Triceratops over the years.
Do you find skulls very often from them, or is it like all the other dinosaurs because their skulls are so fragile? They're pretty rare.
With ceratopsians, it's the opposite.
Yeah,
So it's like exactly, yeah. So yeah, when we find a trike in the Hell Creek, it's usually the skull, and if you get lucky, there's a skeleton with it. So. Yeah, and they're super common out there. Like, they're the most common dinosaur in that formation.
Yeah, some paleontologist kid came in here several years ago and said, the ceratopsians are kind of like the cows of the day because they were like so numerous.
Just everywhere, yeah.
Wow. I gotta go to that. I gotta go see that Hell Creek formation.
Yeah, go visit Museum of the Rockies if you ever get the chance. They've got some of the best Hell Creek displays. Yeah.
That's so cool.
Yeah. I don't know. And right now I'm working on Spinosaurids too, these fish-eating dinosaurs.
Yeah, and they're from where?
Pretty much everywhere except North America.
I wonder, because I've always kind of heard of them coming out of Africa, but they're everywhere, you said, except
Well, yeah, they're from Europe. Like, England has one of the best-known ones, Baryonyx. Yeah.
That's right.
Yeah. And then we're starting to get some out of Asia. There's one from Laos. Ichthyovenator is from Laos. That means fish hunter. We've got fragments of one from Australia now. So, and some from South America too. There's one named Irritator because it was originally like a commercial crew that dug it up and they sold it. And they did, I don't know, they were trying to make it look more valuable before they sold it, so they used like auto body filler to fill in a bunch of the gaps and stuff. And
that's what that pink stuff is.
That's auto body? That's Bondo or something?
Yeah, Bondo.
That's really funny.
Yeah.
On the Alistair here? That's,
yeah, I'm guessing.
I thought that color looked familiar.
They must have ran out of epoxy, or they didn't have the dough to go get other stuff. So we have a big chunk of epoxy on that femur of their visitor center. So
that's really funny.
They put mesh on that femur at the visitor center, and then they put Bondo in that square.
Gotcha.
Well, hello, everybody. Welcome back to Paleontologizing. It is wonderful to have you here today. Happy Wednesday, one and all. I hope you're having a good day. We're going to have a fun stream today. We've got some interesting fossil news to discuss. Not only do we have a brand new iguanodontian dinosaur from the Iberian Peninsula, fellow paleontologist here on Twitch, Dyson Dinosaur, is actually a co-author on that. He sent me a copy of the paper. We'll be looking at it. It's not been named yet, but it does seem to be new. We've got a new publication on Triceratops and anagenesis in Triceratops, kind of like we were discussing yesterday. So we'll be talking about that. And then, of course, we've got Marsh Madness today as well. Two different matchups. We're going to be having, I believe it's Ceratosaurus versus Apatosaurus, and Dryosaurus versus Diplodocus. Hence, our background today is pretty heavily laden with Apatosaurus, Diplodocus, and Ceratosaurus. Didn't have a lot of Dryosaurus stuff yet. I have to change that. We'll see. Anyway, excited about all that. Anyway, welcome to Paleontologizing, everybody. If anyone's here for the very first time, allow me to introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist. Hopefully you know already that a paleontologist is a scientist who studies fossils. I work on dinosaur fossils in particular. Dinosaurs are what I study, what I publish on in the scientific literature, what I present on at scientific conferences, and what I dig up during the summers. In just a couple of weeks here, hopefully going to be back out in the field doing some excavations in St. George, Utah. But yeah, and then after that, the whole month of June, I'm going to be back out there in the field in Wyoming, and then later on in the summer, I'm going to be in Utah at a few different sites, it looks like, which I'm pretty excited about. Anyway, let me pull up for you a quick clip from maybe one of those Utah digs, just to give you a sense for what that field work is like. That should do it.
My game today. I'm glad you could be here again. And hello to you, everybody. Well. It's good to have you. We've got 156 people watching right now.
More than currently. We've got 103.
It's going to be a cool stream. If anybody's got any questions at all about dinosaur paleontology in particular, because dinosaurs are what I work on, what I study, what I publish on in the scientific literature, what I talk about at least 5 days a week when I'm back in my office, or closer to 7 days a week when I'm out here in the field. Or if you've got questions about topics more broadly in vertebrate paleontology, in the history of life on Earth, in science in general, don't be shy with those questions. The whole point of these broadcasts is science outreach, you know? Trying to walk you through what it's like to do science, especially fossil science. And the reason that's possible out here in the middle of nowhere is because of this.
Satellite internet, yeah. Anyhow,
how are we going to do
down
this?
In the quarry.
Put the encoder over here. Hopefully we can still get signal. Good stuff.
Anyhow, we're going to be having more of this next summer from mid-July through mid-August, so I'm pretty excited about that. Yeah. Anyhow.
How have I never heard of that before? Geocore. That's so neat.
Geocore, yeah. It's a cool thing. You know, so I don't know. I mean, I think of it as like a summer internship for college students. I don't know if you specifically need to be a college student.
Anyhow, good stuff. Here's the link to this right there. Let me say hello to everybody in chat, and I'm excited for more digs too, Casey. Very excited about that. More digs, more field work, and more traveling this year as well. Here, I'll show you something that's new today. I finally got myself a piece of rolling luggage, which I haven't had for years and years and years. I wanted to get a nice durable suitcase, and so far it fits the bill. Carry-on size, yeah. I've had so many different times when I've had a big heavy duffel bag with me, and I've got to walk several miles across an airport because the airline changed gates or whatever, or I'm stuck in the airport for 12 hours and it's just a giant pain in the butt. I think having a rolling suitcase, it's not my first instinct, but I think it'll be a big help for some of the travels that I've got coming up. So I'm saving up for that, and now I got it. Anyway, yeah. I've never actually had like a hard rolling suitcase before. It's a first for me. But I'm excited. We're going to be going to SVP this year, hopefully. The Society of Vertebrate Paleontology meeting in the UK, in Birmingham. I'm going to be doing some kind of semi-international travel on top of that. And we'll see what else transpires this year. I might be going to Michigan for a while. Yeah, there's a chance I might be doing some museum visits in the fall. Maybe in Ohio or Pennsylvania. Or New Jersey, we'll see. Oh yeah. And Oblivious Me 3 says, I have so many things I need to catch up on when it comes to paleontology, because I haven't had any time. Well, you're in the right place, Oblivious Me. Welcome back. It's good to see you. Welcome also to Matt M33 and Kodali, who were first today. Long before I started the stream. How are you two both doing? I hope you're having a good day so far. We've got the Lenina. Howdy, howdy, Lenina. Landon History Buff. Welcome, welcome. We've got Arle. Hello, hello, Arle. Hope your day's going well. Jedi Mega Man and Disco Fountain. Bush Doctor and Bonch. Nelf. And Lordy. How are you doing, Lordy? Welcome, welcome. Community time. Hello, hello.
I'm still here. I think after this long we are dating laws.
Executive Storm, thank you for the 56 months of support. I really appreciate that. And again, I apologize for Stream Elements stepping on the TTS for these. One of these days I gotta find the time to move all of my... I've got like 400 different alerts. I've gotta move them all over into Twitch alerts. It's gonna take a while, but... yeah, it'll be good. Thank you. 56 months is a long time, Executive Storm. I think you've got a founder badge there. Good stuff. Thank you for keeping me here online. Crimson Carnotaurus and Damnit Mofos. How are you doing? Hello, hello. Will the next jacketing project go down? I'll probably be helping with some jacketing when I'm in St. George, Utah in a couple weeks. But after that, it'll be in Wyoming, presumably. Who else we got? Casey Snowart, hello, hello. Trader Tots, Charlie's Dragon, Ms. Art Rules, Ari Axis, Frozen Yak, Jazzy Cat, Taxdu, Blame Me For That Loss, hello, hello. Scrolling, Chaotic Time Traveler, What's Shaken, good to see you too. And Blame Me For That Loss says, hey Danny, if you ever traveled through Indianapolis? I have been through Indianapolis. I did a live stream from there. I didn't go to the Children's Museum of Indianapolis, though. I went to the Indianapolis State Historical Museum. Here. Indiana State Museum. Oh. Which was, looks like a horsetail right there. This is pretty cool. Yeah. It was a choice between that and the Children's Museum and being a grown man with a beard walking around by himself pointing a camera everywhere. I didn't really want to go to, like, the Children's Museum. It just felt a little weird, but next time I'm going through Indiana, I'll definitely have to do that because people talk about it a lot. And they even have a couple of like type specimens there, as I understand it. They have the holotype of Dracorex, which is no longer considered valid. And I think they've got a few others, so they've got a decent enterprise going on there. They've got a respectable collections, as I understand it. Let's see. And Crimson Carnothoris, are you going back to the almond or another dig site? No, we're working in the almond again. Yeah, and we've got funding for this year, which I'm really excited about. I was just talking with Ethan on the phone about this on Sunday, and we've got... I can't share some of the stuff yet. I'll probably let Ethan do that if he wants to. But our Ceratopsian that we were digging up over the past few years, we've got some interesting developments from the lab. Pretty exciting. Pretty exciting. Here we go. That was this site here. Doing some jacketing at... Oh, this is great. Claire edited this together. Oh, this is awesome. Fantastic. Yeah. Good stuff. Good stuff. You want the paper? Yeah, me too, Lenina. So this is when we were waiting for the... There we go. For the separator to kind of conform. We were taking a brief respite before... They were kind of teaching Nick here how to mix plaster. So there's Quinn, Nick in the black shirt, and then there's me in the shorts. Doing some jacketing here. Yeah. So again, if you're new to this whole process, this is standard operating procedure when you're digging a dinosaur or any other like largish vertebrate fossil, some inverts too, or even some plants. You create a protective plaster and burlap cocoon around the specimen that helps you get it out of the ground without it crumbling into a million pieces. This is like an essential part of excavation right here. Creating a field jacket, as we'd call it, out of plaster and burlap. Pretty nice. This is some great editing by Claire here. I dig it. Well done. Here's a link to that right here in the chat.
It's squashed completely flat. The bone wall is so
Official
thin,
Curly TV.
it's about the same dimension as the wall of a dirter. A dirter is one of those things you get at the end of the paper towels, the cardboard thing, and
How does it sound?
dirter in it. Well, that's what this thing is like.
There you go. Official Curly TV, thank you for the 9 months of support. I really appreciate that. Thank you, thank you. Good stuff. Anywho, yeah. Blame Me For That Loss says, why did Dracorex lose its status? Well, because it seems to fit into the ontogenetic range of Pachycephalosaurus. So this paper that came out in 2006, I think. Let me find that real quick. 2009, in the journal PLOS One, Public Library of Science. There we go. So here's a link to the paper. It is open access, which is brilliant. No paywall there. But here we go. By examining the skulls of Pachycephalosaurus wyomingensis, Dracorex hogwartsia, and Stygimoloch spinifer, by looking at all of these little bumps and everything, and how they stay consistent across these supposedly different dinosaurs. They've got the same bumps. And then by cutting the bones open and doing histology, You know what? Here, I can show you a clip.
First, so these are dinosaurs that are called pachycephalosaurs, and everybody knows that these three animals were related, and the assumption is that they're related, you know, like cousins or whatever, but no one ever considered that they might be more closely related. In other words, people looked at them and they saw the differences. And you all know that if you are going to determine whether you're related to your brother or your sister, you can't do it by looking at differences, right?
No, look for similarities.
You can only determine relatedness by looking for similarities. So people were looking at these and they were talking about how different they are. Pachycephalosaurus has a big thick dome on its head, and it's got some little bumps on the backs of its head. And it's got a bunch of gnarly things on the front of its nose. And then Stygimoloch, another dinosaur from the same age, lived at the same time, has spikes.
And it might not be like 100% coeval in time. That's an interesting thing. So there's a little bit of a fly in the ointment here. We can discuss that maybe another time if you want to get in depth.
Sticking out the back of its head.
But this is
it's got
kind of a
little
simplified
tiny dome,
version here.
and it's got a bunch of gnarly stuff on its nose. And then there's this thing called Dracorex, Hogwarts eye. Guess where that came from? Dragon. So here's a dinosaur that has spikes sticking out of its head, no dome, and gnarly stuff on its nose. Nobody noticed the gnarly stuff sort of looked alike, but they did look at
Ken,
these.
how are you
together
doing?
and said,
Hello, hello.
These are three different dinosaurs, and Dracorex is probably the most primitive of them, and the other one is more primitive than the other. It's unclear to me how they actually sorted these three of them out. But if you line them up, if you just take those three skulls and just line them up, they line up like this. Dracorex is the littlest one, Stygimoloch is the middle-sized one, Pachycephalosaurus is the largest one.
Yep, so here's the thing. Blame Me for That Loss says, so is it possible to have two juvenile versions of the same creature? In mammals, you don't really get that, because mammals tend to grow really quickly, and the babies are generally like just small versions of adults. Mammals tend to give birth to live young. They've got relatively larger young than reptiles do compared to the adults. With dinosaurs, you're talking about animals that might be enormous when they're full grown, but they all hatch out of eggs no bigger than this, right here. So they all have to start off really small, even if the adults are enormous.
Ontogeny.
Think about like a baby elephant. So baby elephants, when they're first born, are certainly smaller than the adults, but they're not this big. A baby elephant weighs more than I do when it's a newborn. And it feeds on mother's milk until it's time for it to start eating what mom eats. You know, typically in like, what, less than a year or something like that? Dinosaurs are not like this. Look at sauropods, for instance. A newborn sauropod would be no bigger than like, you know, a small poodle or something like that. Maybe a teacup poodle. The adults are gigantic for a lot of these species. This is, I think, Apatosaurus here. And so dinosaurs have got a lot of changing to do. So you can have a lot of kind of intermediate sizes you don't get with mammals. We just don't. Nor do we have that with modern birds either. And so Stygimoloch, at least during certain parts of the Hell Creek Formation, seems to be like intermediate between these. Yeah.
And one would think, that should give me a clue. But it didn't give them a clue. Because, well, we know why. Scientists like to name things. So, if we cut open Dracorex, I cut open our Dracorex, and look at
histology here. Inside. You look at the interior
really
texture of the bone.
I mean, it is a juvenile and it's growing really fast. So it is going to get bigger. If you cut open Stygimoloch, it is doing the same thing. The dome, that little dome is growing really fast. It's inflating very fast. What's interesting is the spike on the back of the Dracorex was growing very fast as well. The spikes on the back of the Stygimoloch are actually resorbing, which means they're getting smaller as that dome is getting bigger. And if we look at Pachycephalosaurus, Pachycephalosaurus has a solid dome, and its little bumps on the back of its head were also resorbing. So just with these three dinosaurs, you can easily, as a scientist, we can easily hypothesize that it is just a growth series of the same animal.
Yep.
Which of course means that Stygimoloch and Dracorex are extinct.
Yeah. The full story might be a little bit more complicated.
I imagine that mammals would still be small creatures
And
like
Gremlin,
this, living in the nooks and
thank you
crannies
for the
of their
follow.
world, and we wouldn't be here.
Welcome to Paleontologizing. It's good to have you here. And blame me for that loss, that's wild how much change happens from juvenile to adult. It's crazy. This is something we talk about all the time. We call it ontogeny. These ontogenetic changes during an animal's lifetime. As they're growing and maturing, their morphology is changing dramatically. So from a baby Triceratops to an adult, those horns start pointing backwards, then they point forwards, then they partly
ontogeny.
Yeah, it's impressive. And you can only see this if you have different growth stages, if you find fossils of different growth stages of the same species. So that's why sample size is so important. That's why it's so important to go out and find more fossils. When you think about it, most dinosaurs that have ever been named are based on one specimen. Most of the dinosaur genus names that exist were assigned to a single specimen. There's just the holotype and that's it. For a few dinosaurs like Triceratops, we're very lucky in that we've got literally hundreds, maybe thousands of specimens. But most dinosaurs are not like that. With most dinosaurs, it's just one specimen. Out of about the 1,000 or so different dinosaur genera that have been named that are probably valid, well, a significant chunk of those are probably not valid just because they're either juveniles or adults of ones that have previously been discovered and named. So as fossil science continues to advance, as we in dinosaur paleontology continue to do more field work, make more discoveries, publish more things, I think we're going to start to see that come to the fore, where a lot of these different dinosaur genera and species that have been named are really just either members of the same species or members of the same lineage, if that makes sense. Sort of like with Triceratops. We'll be talking more about that later when we get to that paper. Yeah. And Craigery says, wow, I didn't realize that most were one of a kind. Yeah, shoot. There, list of dinosaur genera here. There have been a lot of different dinosaurs that have been named over the years. The vast majority of these, I would say, are based on a single specimen. Yeah, right here. Aquilops, I think we only have one of those. Archaeoceratops, I think it's the same deal. Archaeornithomimus, I think we have just one. Maybe, there might be more than one of that. Just in the A's here. But some of your very favorite dinosaurs, some of the ones that get the most attention in pop culture. Critters like, for instance, Carnotaurus right here. This critter is based on one solitary specimen that was published on back in the 1980s. And it's all over the place in pop culture. Yeah, we've got one Carnotaurus skeleton. while it's not complete, it's pretty good. Most dinosaurs that have been named are based on less material than that. You know? Yeah. Yeah. And Craigery says, all the more of a bummer when they get auctioned to private collectors. Yeah, there are absolutely new species of dinosaur that will probably never be scientifically described, despite being excavated, because they were sold off to a private collector. And when something is in a private collection, you can't name it. You can't. It basically doesn't exist as far as science is concerned. Because if something is in a private collection, there's no guarantee that it'll actually be available for scientific study in the future. A huge part of science is reproducibility. You need to be able to set things up so that people in the future can test your work. And so if you don't have that, then you don't have much, you know? It's kind of an essential part of science, is this idea of reproducibility. But yeah. And is there a certain percentage of the skeleton that would make it feel more valid in your eyes? You kind of answered your own question there, Casey. Certain bones are more diagnostic than others, yeah. You would never name a dinosaur based on just like a fragment of a rib or something like that, unless it's extremely distinctive. Spicomelus is probably an exception to that rule, because all we really do have are some fragments of ribs, but the ribs have spikes on them. Like, what in the world? But yeah. But usually ribs are pretty non-diagnostic. For Carnotaurus, it was pretty obvious that that this critter was new, because it was unlike any other abelisaur that had previously been discovered. Where is that image? Skeletal diagram. There's a really good one where it actually shows what we have and what we don't. And you know, let me try DuckDuckGo. It's often better. Skeletal. Bingo. That's what we wanted right there. Yeah. So this is what we actually have of Carnotaurus. We're missing most of the tail and the distal parts of both hind limbs. It does make me wonder whether these are just eroded away right here from the proximal end of the tibia on down, or maybe they accidentally dug through it or what, but this is what we have of Carnotaurus. This is all that exists in the world, as far as I know. All that's ever been published on, at least, of Carnotaurus. But here we actually have, it was so well preserved that we've got fossil skin impressions, exquisite detail on much of the skull. It's impressive, but we don't even have the whole body. And this is doing pretty well. A lot of dinosaurs are known from far, far less than this. And Kennedy says, I believe Danny said the skull is usually the most valuable for science. Yes. And it makes sense when you think about it. The skull is the most informative part of the skeleton because it houses most of the sense organs. You've got the eyes there. You've got the brain in there. You've got the nostrils. It's the business end of the animal. You've got the teeth, if the animal has teeth. You've got the jaws. There's so much there. So the skull is also usually the part that evolves the fastest too. Like you'll notice something with the emotes that I put together. Think about the ceratopsian emotes that I have. Styracosaurus and Navajoceratops and Triceratops there. You've got these different heads, but it's the same body for each one, because ceratopsian bodies don't evolve very quickly. So the horned dinosaurs, ceratopsians, their bodies tend to be fairly nondescript. They tend to be pretty similar to one another. It's the headgear that changes, and changes pretty dramatically. So if we were to look at this image here, this is lovely. First time I've seen this. Too bad it's on Reddit. We can't really embiggen it properly. But yeah, you know, pretty standard bodies for all these guys. And some of them, the tail is a little bit longer, a little bit shorter. You know, have slightly longer hind limbs compared to forelimbs, or vice versa. But it's the headgear that changes. It's kind of nuts how quickly these horns and frills evolve over time. So if you've got a ceratopsian dinosaur, a horned dinosaur, especially a ceratopsid, you need parts of the skull if you want to be able to name it. That's why my crew is going back to Wyoming this year, and we're going to be doing a lot of work at that ceratopsian site to try and find more of that skull, because we've got some really intriguing bits here. It's probably enough to, I guess, to name a new genus or species, but we want more. We want to have as solid a paper as we can. We want to do science that is as rigorous as possible. So it, you know, this would be our third year. This will be our third year digging at that site. Because we need more of that skull. Yeah. And Casey says, I'm so curious how many of these are actually ontogenetic stages of each other. So there's ontogeny, but there's also evolution, anagenesis, and cladogenesis. For some of these, I think Torosaurus, which is what, right here? It's a weird looking Torosaurus, but yeah. I think Torosaurus is probably a fully adult Triceratops from low down in the Hell Creek. You've got heterochrony going on too. And there's a few more like this where I suspect that Avaceratops might be the same thing as Furcatoceratops, and that's part of the Nasutoceratops lineage. Several of these guys are going to be maybe the same lineage over time, just give it a few million years or even a few 100,000 years for them to change. These dinosaurs change really, really quickly. Really rapid evolution in ceratopsids throughout the late Cretaceous. So, again, it gets into this question like, is it really a new species? If it's the same population over time, that same gene pool, just kind of changing bit by bit until 100,000 years later it looks a little bit different, is that actually a different species? And if it is, when did it become a different species? When do you draw that line, you know? That's the thing, is that when scientists came up with this like species concept, they didn't really understand evolution. They didn't really understand that living things change over time, and that one species can evolve into another over time. Like, species are not fixed, they change. And it's kind of like a ship of Theseus sort of problem, if you're familiar with that. Ken says, I'm all about the ecological species concept. Well, even that has its... No species concept is flawless. All of them have got their squishy gray areas and stuff like that. Here we go. So what do you call this? A thought experiment or a paradox, or what would you call it? Now let's take a look at this. Let's be short.
Here's Theseus, and here's his ship. Over time, pieces of his ship need to be replaced, and after many voyages, not a single original plank remains. Now imagine someone collected all the pieces that Theseus threw away, and over time, used them to construct an identical ship. Now which one is Theseus's ship? This question becomes even more interesting if you replace his ship with our bodies. Many scientists believe that our body completely replaces all
many scientists believe. It's not every cell in our bodies that gets replaced, but it's a lot.
Cells roughly every 7 years. If that is the case, what then makes you, you?
Anyway, Ship of Theseus. So, again, there's like this... Do objects survive change?
For Wang. I'm a professor of philosophy at the University of Georgia. Today I'm going to talk about the Ship of Theseus puzzle. This puzzle was recorded by Plutarch, an ancient Greek historian, though it's come up in many different forms over the ages. It goes like this. Theseus was this great mythical hero of Athens who sailed off to Crete and slew the Minotaur, a creature with the head of a bull and the body of a man. After Theseus came back, his ship was left in the Athenian harbor as a memorial. Over centuries, the planks of the ship decayed and were gradually replaced. Now, it doesn't really matter that the planks decayed or that the ship still had masts and sails and other ship stuff too. We can simplify the story. Let's pretend that the Ship of Theseus is a very simple ship made of 1,000 planks and nothing more. Let's also say that the planks are made of invincible wood, superwood, so that they never decay.
Oh boy.
In what I'll call Scenario 1, the Ship of Theseus has its 1,000 planks replaced very slowly over the course of 1,000 years. That's 1 plank a year. So here's the puzzle. Surely, a ship can survive the replacement of one of its planks. In year 1, when the first plank is replaced,
Anyway,
it's still the Ship of Theseus.
I'm going to get to the point here. How many planks do you have to replace before it's no longer Theseus's ship anymore? You know? At what point do you draw that line? It becomes kind of arbitrary. And at the same time, when we're talking about anagenesis, when we're talking about a population of organisms slowly changing over time, as long as there's no splitting event where it splits into 2 new species, if it's just that parent population slowly changing over time, at what point does it become a different species? How different does it have to look? We don't have a solid answer for this because, again, the whole species concept thing, this is sort of come up with before we understood evolution. You know? So, when we're looking at Triceratops evolving over time, we had 2 different species of Triceratops that are considered valid. Othniel Charles Marsh named both of them. Triceratops horridus and Triceratops prorsus. Marsh kind of assumed that these animals lived at the same time and there's different species of Triceratops. You know, interacting, living in the same kind of environment, whatever. But when you actually look at where all of these different specimens come from in time, when you match them all up to the rocks that they came from, and you stack them up like that, turns out Triceratops horridus is only from the lower Hell Creek, or like the upper part of the lower at least. For simplicity's sake, we'll say from the lower Hell Creek. And Triceratops prorsus is only from the upper Hell Creek. And you have this one here in the middle that's not yet been named. The Yoshi's trike specimen is one of these. You actually have 2 different kinds from the middle. And so it seems like kind of a smooth gradation from small nose horns here at the bottom. They get larger and larger over time. And so you end up with Triceratops prorsus with that big honkin' nose horn there. Now, we call them different species because it's kind of a historical artifact. This is, it's kind of a leftover from Othniel Charles Marsh's day. He didn't realize that there's a smooth gradation there, it seems. We didn't really know this until, like, the mid-2010s, when this is first published. And it took a ton of field work and a ton of work in the laboratory and the museum collections to figure this out. But yeah. So is it really 2 or 3 different species? Or is it better to think of it as just one population slowly changing over time? We still call them different species just because it's sort of convenient to do that. You know, Triceratops prorsus versus Triceratops horridus. But it's not like, it doesn't seem like they actually had a splitting event. A cladogenetic event where they actually, one species split off from the other. It's just slowly over time, whether it's through natural selection or maybe just genetic drift, maybe just kind of directionless change over time. They changed over time. So yeah, does that make sense? Yeah. Anyhow, yeah. And Casey Snowart says ring species are a great example of how this works over time. Yeah, actually, let's take a brief look at that, because I think that'll be helpful before we get into our Triceratops thing. Species concepts. What is a species? This'll work. I know we've watched this before.
Classifying living things
but...
is kind of like Pokemon. It appeals to our instinct to collect and identify.
Yeah, unlike Pokemon, you're not forcing creatures to fight each other against their will, however. So, I don't know, I'd say it's better than Pokemon.
And the fact that we have a classification system is super useful for scientists. I mean, it shows how every type of organism we know is connected to all the others. We've mapped out all of life in one giant chart. It's amazing.
Oh, and Ken asked a really good question here. For descriptive reasons, it's better to label them differently. Also, how do we not know that prorsus and horridus didn't come from a branch in the late Campanian? Well, here's the thing. We don't know for sure, but there's ways of testing that hypothesis. Because if you ever find a Triceratops horridus in the upper Hell Creek, where it's only supposed to be prorsus, that would be a neat falsification of that idea. It's like, oh shoot, that's not anagenesis. They must have split at some point in the past, but that's never happened before. And you could say, well, you know, you're only looking at a very limited basin. You're looking at the Hell Creek Formation of Montana. You know, maybe up in Canada, you still have a relic population of Triceratops horridus in the upper Hell Creek. But the thing is, you can go up there and look. And that's what this paper is about today. They did that. And it's all prorsus up there. It's exactly what you would expect if it's just one population changing over time. I was talking with Denver about this, Denver Fowler, when I was in North Dakota back in February. We were talking about anagenesis in dinosaurs and why many dinosaur paleontologists are so hesitant to give the idea the time of day, to give it any thought whatsoever. And he said it doesn't make sense that people don't want to think about anagenesis, because it is the more testable, more falsifiable, more, frankly, scientific way of looking at things. You can always claim that, oh, there must have been a magic splitting event at some point in the past. There must have been a cladogenetic event. We just haven't found it yet. You're going to assume that's the case. Like, okay, that's an easy, safe, kind of feckless assumption to make. Anagenesis, in putting forth that hypothesis, you're putting your money where your mouth is. You're saying, hey, cards on the table. I'm saying that this is one continuous population changing over time, and you can falsify that with one single specimen, if you can find it. Anagenesis is falsifiable. Cladogenesis kind of isn't, you know? It's almost a special pleading. It's almost a logical fallacy. Like, you can always say, well, there must have been some splitting event at some point. Who knows, you know? Sure, there could have been, but science is about testing ideas. An idea is not a strong one in science unless it's falsifiable. The strongest ideas in science are the ones that are bold and you could, with a single piece of evidence, disprove them. if one of those bold ideas sticks around for years and years and years and nobody is able to disprove it, even though it would be really simple to, that's a really powerful idea, because that means, like, maybe it's true, you know? If it would be super simple to falsify, and yet you can't, yet all of the evidence supports it, that's a strong idea. Does that make sense? Oh, yeah. Yeah. Anyhow. Let's continue with this about species concepts before we get into our Triceratops paper here. Yeah.
Amazing when you think about it. But deciding how to...
Oh, and Ken says, I think the anageneticists overestimate how big the snapshots are. Big this... I don't know. I don't think I understand, Ken. What do you mean? How big the snapshots are?
Classify a new type of organism often isn't simple, especially when it comes to assigning it a species. In some cases, it's obvious when two things should be separate species. A jellyfish clearly is very different from a jaguar. But the more similar organisms get, the harder it can be to sort them. There's no one rule that will always tell you whether two organisms should be in the same species. So different taxonomists use different rules in different situations. The most widespread...
So here's the thing, is that species is kind of a man-made concept, sort of, in the sense that it doesn't have, like, hard and fast boundaries around it. Like, yeah, we often use it as a term of convenience. There is a real biological reality to species, but they're a bit more wishy-washy, especially around the edges, than many people realize. You know?
Spread definition of a species is called the biological species concept, or BSC. It was popularized by evolutionary biologist Ernst Mayr in 1942, and he continued to refine the idea over the next several decades. According to the BSC, organisms are part of the same species if they can produce offspring that can also breed. If they can't produce fertile offspring, that means they belong to separate species.
So, if we're using the ability to produce fertile offspring as our definition for species, where would that bring us some problems when we're talking fossils? If reproduction is your litmus test, why might that be a stumbling block for paleontology? You know? Any ideas? There we go. If you typed or were thinking some variation on, well, fossils are dead, so we can't really tell whether two different individuals could reproduce, you're right on the money. Yeah. Fossils famously do not breed, says Lenina. Yeah. And Ten Fingy says, what about cross-species breeding? That's a really good point, Ten Fingies. We'll talk about that too, because sometimes even species that are not super closely related can still produce fertile offspring under certain circumstances. So again, this biological species concept is limited in its utility. There is no perfect species concept. When we're trying to, like, define what is a species, when you're trying to actually come up with a definition for that, it's tricky, because nature is complicated and complex and doesn't like to play by human-created rules, you know?
BSC hinges on the idea of reproductive isolation, where something separates two species to the point that they're not compatible anymore. That separation could be time, or geography, or behavior, or physiology. Alder and willow flycatchers used to be considered part of the same species because they meet up in the wild, they look the same, and it seems like they should be able to breed. But ornithologists eventually realized they're totally different species. They sing different songs to attract different mates, so alder flycatchers never try to mate with willow flycatchers.
And so the thing is here, this would have been a recent split. Alder and willow flycatchers. I bet you we can look them up on our Tree of Life here, actually. There we go. Willow flycatcher. Zoom into there, and I bet you their sister species will be the alder flycatcher. So these are two different species that came from the same ancestor. There's the willow flycatcher, Diplodocus tralei, and the alder flycatcher, Diplodocus alnorum, rather. And so they diverged about 1.94 million years ago. So about 1.94 million years ago, we'll say 2 million years ago. 2 million years ago, these were the same critter. But there was some sort of event that happened that caused that population to split. So that population diverged. And the two parts of it became different enough that they slowly became different species. And today we could call them different species. And they're so similar because it was very recently that they diverged. Does that make sense? Yeah.
The reproductively isolated. A species is therefore basically a gene pool, one that doesn't overlap with the gene pools of other species. That's a good, rigorous scientific definition. It can be tested and observed in the wild. But there are lots of cases where it doesn't work, like with microorganisms. Bacteria, for example, don't reproduce sexually. They can share genetic material with each other, but it's not part of the reproductive process. So reproductive isolation is totally irrelevant, and a scientist looking to classify a new species of bacteria can't rely on the BSC.
So yeah, biological species concept is just one of these species concepts that we have, and it's good for certain critters and not good for other critters. It's good for creatures that you can test whether they actually breed in the wild. But since bacteria don't reproduce sexually, it's no good for bacteria. It's a bad litmus test for them. Likewise, it's not good for fossils either.
Instead, they might look at genetics, at the shape of the microorganisms and the way they grow, and at their evolutionary relationships to other organisms. You also can't use the BSC to classify fossils, since you can't exactly observe the mating behavior of a skeleton preserved in rock. Sometimes you get unbelievably lucky and two specimens are preserved while they're mating, but that's way too rare to be definitive about which animals mated with which other ones.
So I think there was fossil turtles? Yeah, two of them were found. They died while doing the deed. But this is exceedingly rare. This basically never happens. So we can tell they're the same species, or at least it seems like it. I guess we don't know if they would have produced fertile offspring because they both died. But yeah, this essentially doesn't happen. So what's our species concept for fossils then? You know? How does that work?
Paleontologists usually use morphology, or the physical characteristics of a creature, to classify it. Then there's the issue of hybrids, where creatures that should be part of separate species.
So hang on, he cruised by that pretty quickly, but the morphological species concept is what we usually use in paleontology. Morphology is the form, the shape, the anatomy of the bones, the parts that we have of an organism. We look at their shape and everything, and if they look similar enough, maybe they're the same species, you know? That's kind of the paradigm that we use in paleontology, the morphological species concept there. Because that's what we've got. We can't observe the mating behavior of extinct animals because they're extinct. We can't look at the genetic code of these animals to figure out if they're the same critter. Because DNA doesn't fossilize like that. It doesn't last very long. It's very fragile. It's got a real expiration date on it. So we have to look at morphology. We have to look at the shape of the bones and the teeth and the scales and everything else.
Creature to classify it. Yeah. Then there's the issue of hybrids, where creatures that should be part of separate species mate. When two species hybridize, there are a number of things that can happen. Often, even if they produce offspring, the offspring are sterile. That's what happens when you cross a female horse and a male donkey, for example. The offspring are mules, and mules can't breed.
Except under very specific circumstances. I think there were a couple of mules that did actually turn out to be fertile, but it's a real fluke. They're not normally fertile.
But sometimes two species can produce fertile offspring, and biologists have found that animal species hybridize way more often than we used to think. If the offspring go on to mate with their parental species, it's called introgression. It provides a means for gene flow between two species, meaning their gene pools aren't totally isolated. So does that mean
And Casey Snorritz says about the mules, yeah, there was one recently. They had a chromosome thing going on. Well put, Casey. Yeah. Yeah, you know, I got a chromosome thing going on. Yeah. You want to come over later? We'll get a chromosome thing going on. You know, I know what you mean, Casey. It was funny the way that you said that. Yeah. Yeah.
And that you have to revoke their status as separate species?
Yeah.
Scientists haven't settled that question yet, but some think that the gene flow between two species, meaning their gene pools aren't totally isolated. So does that mean that you have to revoke their status as separate species? Scientists haven't settled that question yet, but some think the barriers between species are much leakier than the biological species concept allows. Sometimes this leakiness can lead to two groups being classified as subspecies within a single species. Subspecies give you a little wiggle room. Sometimes organisms overlap geographically and can share genes. In cases like these, subspecies means we know that they can share genes. It's just that they usually don't. Then there are ring species.
Yeah, so anyway, when we're talking about hybridization, like two presumably different species that can still produce offspring, sometimes fertile offspring, those are usually species that are very closely related. They only recently diverged. Like, for instance, I betcha if you held them both in captivity and they had no other options, I betcha you could get alder flycatchers and willow flycatchers to reproduce. Because it was only very recently, like 2 million years ago or fewer, that they actually split. So their genetic codes are still very, very similar. Their reproductive systems are probably very, very similar still. You know, it was only 2 million years ago that they were the same thing. You know, they've only been evolving in separate directions for 2 million years. So somebody in the chat was asking about whether different dinosaur species or genera could interbreed, and they gave an example. I think it was like a ceratopsian and a hadrosaur. Those are creatures that are separated by tens of millions of years. Not a shot that they can interbreed. Just doesn't happen, you know? It's like expecting a lion to be able to have offspring with a goat, you know? Like, they're way too different nowadays. It's not going to work for multiple different reasons. However, there are sometimes really weird examples of this. Like the sturtlefish. This is
making
bonkers.
Successful
yeah, this is wild. Different size show.
There's a reason you don't see hybrid animals like ligers running around very much. Not only are they separated by geography, but the genes of different species don't usually play well together. But recently, researchers in Hungary accidentally crossed two very different fish, the Russian sturgeon and the American paddlefish.
So these are two different critters that have been separate for like 100 million years or more. So let's jump to paddlefish here. There's the Chinese paddlefish, which is now probably extinct, unfortunately. Our tree of life, that's going to be over here within our ray fin fishes. Chinese paddlefish, American paddlefish. And then you get your sturgeons here. So the last time that sturgeons and paddlefish had a common ancestor was about 184 million years ago. This is when these two groups split. So they've been evolving in separate directions for about 184 million years.
Their research was published in the journal Genes, documenting hybrid fish that, according to what we know, were not supposed to be possible. These scientists didn't set out to make a hybrid, though. They were originally trying to create sturgeon offspring that had only their mother's DNA through a process called gynogenesis. Usually, this process involves fertilizing egg cells with deactivated sperm cells from another species, making it possible for only the mother's genetic material to be passed on. In this experiment, the researchers crossed sturgeon eggs with paddlefish sperm.
So again, these are two wildly different fish. Like, they look very, very different. I know here on this tree, they don't seem like they're that far apart, but that's just because both of these groups used to be far more diverse, and they had a lot of different species, and then most of those species have since gone extinct. So, you know, there's only two remaining species of paddlefish, maybe just one, actually. Chinese paddlefish is probably extinct. And, we've got about 22 species of sturgeon. But everything in between here, all of the different species that, would kind of fill out this tree, those are all gone. And so while it might look like these critters are very closely related, they've been evolving separately for almost 200 million years at this point. So they are not close at all.
The researchers crossed sturgeon eggs with paddlefish sperm because they thought it wouldn't create hybrid offspring. These fish are fairly distantly related, and until now, nobody had been able to make a sturgeon paddlefish hybrid, and they'd tried. So that was finding number one. It turns out it is possible. Then the researchers got to work analyzing the anatomy and genetics of the offspring, and what they looked like depended on what kind of chromosomes they inherited, or really how many. See, at some point in evolution, this group of sturgeons acquired another 2 copies of their chromosomes, giving them 4 copies of each chromosome, where paddlefish only have 2. And
so, they got a chromosome thing going on, like, is not what I would say. But here it's like, it works to their detriment. Like, the sturgeon genome is like twice as big as the paddlefish genome. So this should not be possible based on our understanding of this. Like, based on a really simple understanding. It's like, well, the genome is twice as big in the sturgeon? There's no way these critters could reproduce, And
in the world of fish hybridization, when parents with mismatched sets of chromosomes reproduce, their offspring can inherit different numbers of sets. And sure enough, the offspring in this experiment could be split into 2 different groups. Some were triploid, meaning they had 2 copies of the sturgeon mom's chromosomes and 1 copy from paddlefish dad for a total of 3 full sets. Or they were pentaploid, with 4 sets from mom and 1 set from dad. Now,
what's really cool, too, is this actually affected how they would look. So, like, the pentaploid ones, where they've got 4/5, sturgeon chromosomes, they look much more like a sturgeon. They still look weird. They still got, like, weird paddlefish traits there, like that lengthened upper portion of the caudal fin. But the ones that are just 2/3 sturgeon, they look a little bit more paddlefishy. They've got a longer rostrum there, like on a paddlefish, Wild. This is so cool.
Now that's a little strange because in birds, mammals, and reptiles, having more than 2 sets of chromosomes can lead to serious errors in cell division, and it's usually fatal. It's more...
So that usually breaks the whole organism. If you've got, like, the wrong number of chromosomes, for a lot of organisms, if there's a mutation that causes that, if that arises, it's like, you're done for. Like, you're not even going to be born properly. But in this sturgeon paddlefish hybrid situation, it worked for some reason, and I don't think it's still fully understood why that is.
More common in fish, it may have even been an advantage over their evolution, but only in even sets of chromosomes, 2, 4, 6, 8, and so on. Organisms with 3, 5, or 7 sets of chromosomes usually run into fertility problems.
This is exactly what Charlie's Dragon is saying here. Not having fertile offspring, at least. That's what makes mules not fertile. Horses and donkeys don't have the same number of chromosomes. Yeah, but for these guys...
In this experiment, the number of sets of chromosomes in the hybrid offspring depended on what they inherited from their parents. The offspring with 3 copies of their chromosomes looked like a pretty even split between sturgeon and paddlefish, while the offspring that got more sturgeon chromosome copies looked a little bit more sturgeon-y. Now, if these 2 fish weren't supposed to be able to reproduce, how'd they pull it off? Well, while these 2 families of fish split a long time ago...
Like 200 million years ago. Long time ago.
The researchers think that their relatively slow rate of evolution means their genes and anatomy hadn't actually diverged that much.
So what's crazy is that even though in terms of absolute time, they've been separate for 200 million years, give or take, these are 2 lineages that seem to evolve really slowly. They might have really low mutation rates. They have very, very long lifespans too. Sturgeon are famously very long-lived. The very largest sturgeon are like maybe over a century old. And I think they need a long time before they're actually sexually mature, before they can actually reproduce. They might be like 20 years old or something before they can start having their first offspring. And so that's part of being an animal that evolves more slowly, if that makes sense. Because they've been evolving so slowly, even though it's been 200 million years or so, they haven't actually changed that much genetically in the ways that matter for this circumstance.
And the fact the sturgeon had 4 chromosome copies might have set up these two fish for increased chances of making successful babies. That's because past fish hybridization experiments have shown that when the mother has more chromosome copies than the father, the hybrid offspring have better odds of survival. So now the researchers are looking into filling up fish farms by making more of these sturgeon hybrids, just on purpose this time.
Interesting stuff. Here's a link to this video right here. Good work from SciShow there. Maybe better for the environment, not necessarily dinosaurs, but those thousands of species of fish and mammals and others, if they still existed, how would that affect the planet? So blame me for that loss. That's the thing, is that extinction is a part of evolution. The creatures that are around today, you know, you walk out of your house and you look around and you see perching birds, you see various kinds of insects like honeybees and stuff like that. You see squirrels running around and people walking their dogs and everything else. None of those creatures existed during the time of the dinosaurs. It's only because of the extinction of the non-bird dinosaurs that these creatures were able to evolve in the first place. Creatures change and evolve, lineages evolve over time to become better suited to their environments. And so those changing conditions shape the evolution of organisms over time. And so it would not be better for the environment today if you had if in a Jurassic World Dominion sense, if there were Allosaurus and Tyrannosaurus and Parasaurolophus still running around today, that would not be good for the creatures today, probably, you know? Does that make sense? Yeah. Anywho, yeah. Anyway, let's get back to the species concepts, and let's get back to ring species here. Hey, Science Streams could see Balint here could talk about this with far greater authority than I could, because he actually works on genetics and heritability and all of this stuff. Yeah, species aren't real, so that's what we're talking about, Balint. Yes, exactly. It's funny. If any taxonomic ranking within taxonomy is real, it's only species. Only species are real, but even they are wishy-washy. There's gray areas. There's, yeah, as you'll see here. Yeah, Science Stream says the definitions drive me crazy. Yeah, that's why I have some colleagues who, I don't know, people like, you know, Denver Fowler could tell you about this. He says, I kind of hate using genus and species names to refer to different dinosaurs. He's like, sometimes it's much simpler just to refer to the individual specimen numbers, the individual specimens, rather than talking about genera or species, because you can get individual variation, ontogenetic variation, all of these other things that make these creatures different or similar. And then you throw geologic time and evolution into the mix too, and you've got like multiple axes of change and variation, and it just gets really complicated. So yeah. Anywho, to help illustrate this point, we've got ring species here. Oh, and Science Stream says, you pointed out to me once the most critical part of species when dealing with dinosaurs. If you had a spectrum of bones showing evolution of the animal, at what point is it a new species? That's exactly what we were talking about, Bolin. Yeah. And we've got a new paper about this for Triceratops that just came out today, too, that we're going to take a look at in a minute. Yeah. That stayed with me. There you go, science streams. Yes. Yes. Here.
In California, for example, there's a species of salamander that lives in overlapping populations of subspecies on either side of the San Joaquin Valley in a big elongated ring. Those subspecies can all interbreed except for two. At the southern part of the ring, two subspecies can't interbreed. So, according to the BSC, those two subspecies should actually be separate species. But even though they can't interbreed, genes can still flow between them through the other subspecies. Where does that put them? You can't answer that question with the BSC. So having a hard and fast definition of species that you can test and demonstrate is useful, like in conservation when you're looking to protect a species and its habitat, but the biological species concept isn't an absolute rule that scientists are bound to. It's a tool, and scientists try to select the best tool for the job.
So again, with that ring species there, again, you've got different colors here are different subspecies. And so the blue ones can interbreed with the green ones, who can interbreed with the yellow ones, who can interbreed with the red ones and the orange ones, who can interbreed with the pink ones, and then the purple ones. But the purple ones and the green ones can't interbreed. So I think presumably these guys, I don't know, maybe I'm making up a story here, but for the sake of argument, let's say that they originated here. Let's say the blue one is the first species. And then you've got the green ones that become a separate population, and they're in the process of speciating, but they can still interbreed. And then they move up the coast, and then the ones in the yellow here, they've got a slightly different habitat, and so they've evolved to become suited to that habitat. They can still interbreed with the green ones, but then the same thing happens again with the red guys, and they really move all the way up the coast here. They're super successful. You have a little subpopulation here that's starting to speciate too. And then you keep doing that. And by the very end, the purple ones and the green ones, purple ones move all the way down here, and suddenly they're too different than the green ones. They can't interbreed, even though purple can interbreed with pink, who can interbreed with red. You can still get genes that can flow all along the line here in a ring, but at the part where that ring closes up, those two can no longer interbreed. They're just too different.
Species on either side of the San Joaquin Valley in a big elongated ring. Those subspecies
so there you go.
Can all interbreed except for two.
Yep. Does that make sense? Wild to think about. So is this one here, is green a different species from blue? Blue can still, since all of these different populations that live next to each other can still interbreed, you could still get genes, like different mutations that arise in blue and start to spread throughout the population. They can spread through all of these subspecies and still get the green, even though these guys can no longer interbreed directly. Wild, right? This is so cool. Blue is a different... There you go, Lynette. You're talking about your partner, Blue. Yeah, I got it. But yeah. Yeah, wild.
The southern part of the ring, two
and the guard paper, yeah.
So according to the BSC, those two subspecies should actually be separate species. But even though they can't interbreed, genes can still flow between them through the other subspecies. Where does that put them? You can't answer that question with the BSC. So having a hard and fast definition of species that you can test and demonstrate is useful, like in conservation when you're looking to protect a species and its habitat, but the biological species concept isn't an absolute rule that scientists are bound to. It's a tool, and scientists try to select the best tool for the job. That might be the BSC, and it might not. It depends on what you're studying. Thanks for watching this episode of SciShow, which was brought to you by our patrons on Patreon.
No, there you go. Here's a link to this video right here. Yeah. So we've got that. We've talked a little bit about how species concepts can be really wishy-washy. How we as human beings, scientists, do our best to come up with definitions for things that seem helpful. But we gotta remember that those definitions are meant to serve us and not the other way around, We're not working in service of those definitions. They're a matter of convenience. They're tools for helping us do what we do. They're our attempt for trying to understand nature, when nature is often much more complex than those simple definitions. Have I gotten that idea across well enough? I hope so. Anyway, with that being said, let's talk about anagenesis versus cladogenesis here. So in evolution, in speciation, well here, I think there was another video that talks about this that'll be more fun than me just trying to explain it with some visual aids. Yeah. There we go. Lovely video from the Amoeba Sisters here.
So if you've seen our videos before, you may know that one of us is a cat person. Well, the other one of us is a dog person. And when we were younger, we used to wonder, wouldn't it be cool to have
There you go, Lordy.
one
Yeah,
animal
yeah.
that is half dog?
And Gay Hibiscus says, I work with plants and smaller animals, and honestly, we use subspecies and locales a lot more than we use species if we're working in a general area like a province. There you go. And so organisms that tend to be smaller and have a smaller geographic range, subspecies might actually be the more useful kind of concept to use in a situation like that. If you don't have gene flow across an entire continent, then of course they're going to use subspecies. But generally the larger organisms are, especially animals, the wider range they have and the further distance they can throw their genes, so to speak. So, like, elephants can walk across a continent if they want to, you know? It's more difficult to get them to speciate because they need a wider range. They do a lot of traveling during their lives. And so you might have one species for an entire continent. Whereas for little plants or little animals or other organisms, they don't need as much space. They might stick closer to home. They're not going to be marching across an entire continent to spread their genes. And so it's more likely that they will become kind of a local subspecies and eventually a local distinct species. Because, you know, they're just reproducing in one place and they can adapt to local circumstances and evolve over time to just be kind of particular to that one area. This is an interesting thing when we're talking about dinosaurs, because here, do I have faunal endemism? Here we go.
This is the kind of thing you would have seen.
So this is Scott Sampson. He doesn't really work on dinosaurs much anymore, but if any of you have kids in the chat, if you're familiar with Dinosaur Train, this is Dr. Scott, the paleontologist. Here's Scott Sampson here talking about this.
At speeds of 40 miles an hour or so, something in that realm, we're not really sure. And we don't know for positive sure, but we think that they may have been omnivores, eating both animals and
plants. We were talking about this yesterday.
So this is the kind of thing you would have seen looking out your window if you had a house on the coast of Laramidia 77 million years ago. Now, starting in the 1960s, paleontologists began to notice that the dinosaurs they found all the way from Alberta down to Texas were the same groups of dinosaurs. They always found tyrannosaurs and horned dinosaurs and duckbills, etc. But they appeared to belong to different species, different organisms at the species level. So it's like having different kinds of birds or different kinds of big mammals, you know, like a black rhino and a white rhino, for example. But the strange thing was that everywhere we looked, there were different species. So same groups, but different kinds at that lower level, which was very weird, because you have to remember that Laramidia is only about 1/5 the size of present-day North America. And it appeared that there were well over 24 giant animals, well over 1,000 kilograms. Now compare that today with Africa, where we think of the big animals living. There's only about 5 species of animals in Africa that exceed 1,000 kilograms, things like elephants and giraffes and rhinos and hippos. Only 5, covering the whole continent.
Elephants, rhinos, giraffes, hippos. What's the 5th one? Would it be Cape Buffalo, maybe? It's probably Cape Buffalo.
Now we're talking about an area that's 1/5 the size, that has well over 24 giant animals. And there's a good reason why there's not so many today in Africa. Some may have been wiped out by us, but there's other reasons, and it has to do with making a living. There has to be enough food to support all those different species if they're going to persist over a long period of time. So when I started working in Utah, there was a mystery to be solved. And that mystery was this: how could so many different kinds of giant animals live together on such a small chunk of land, a little bit of real estate? And when we thought about it, we really could come up with only 3 reasons to explain how you could have different dinosaurs living in Montana and Utah. Why would...
Yep. So what we're going to say here, Scott Sampson's going to give his hypothesis, and this is kind of what he's built part of his career on. Not everybody agrees with this. There are some paleontologists who work on the dinosaurs of Laramidia who say this is completely wrong. We'll talk about why, and I'm going to kind of show you both sides of this.
Wouldn't they be the same ones? And our 3 reasons were, these 3 possible solutions were, the dinosaurs maybe didn't coexist. Maybe they lived at different times.
So yeah, when you're looking at this map, I wish you would show the map during this part because that would be helpful. Oh well. Anyway, the reason why they're different is that, well, shoot, of course they're different. We're looking at different times here. As these animals are evolving pretty quickly, if you're grabbing snapshots of these lineages from different times, then of course they're going to look different. This is what people like Denver Fowler are convinced of right now. Shoney53, thank you for the follow. Welcome to Paleontologizing.
Remember, we think in these very short time frames, maybe these dinosaurs appear different just because we're sampling periods that are millions of years apart. And maybe if we could really sample the same time periods, we would find that they would be exactly the same animals north and south on Laramidia. So that was one hypothesis to be tested. The second hypothesis is that there was just a whole lot more food around back then to support all these different dinosaurs.
I wonder about that.
And the third hypothesis...
Like, that's something that, it's an extraordinary claim I think requires extraordinary evidence. There was just that much more food back then?
Is that the dinosaurs didn't eat as much to make a living. So if they don't have to consume as much food, maybe there could be more species around.
And I feel like this is kind of an oversimplification too, because yeah, I don't know. Anyway, we don't have evidence of this. Like, we have evidence that most of these dinosaurs were probably endothermic, warm-blooded. They would have required a tremendous amount of food. In a lot of cases, more than like an equivalent-sized mammal today. So yeah.
And you have to remember, dinosaurs are reptiles, and reptiles today are cold-blooded. And if you think about cold-blooded versus warm-blooded animals, reptiles are like the Toyota Priuses of the animal world. They don't need to eat very often. A crocodile can
excellent fuel economy
and then not eat again for weeks.
On
a lion of the same size eats and then has to eat again within a few days. So mammals like us, we're the gas-guzzling SUVs of the animal world. We have to consume a lot of food to keep our internal flames, internal fires stoked. So which were dinosaurs? We don't know.
Well, I mean, most of the evidence that we have is that most, if not all, dinosaurs had elevated metabolisms. They maintained their body temperatures internally by burning calories, and so they would have needed a lot of food.
I think my guess is we're going to know for pretty certain within the next couple of years, and I have strong biases about it, but we haven't been able to demonstrate it for sure one way or the other. So keep these ideas in mind.
If there is a strong consensus right now, it seems to be leaning in the direction of most, if not all, dinosaurs being endothermic, warm-blooded, burning a lot of calories to keep warm, or cool in certain circumstances.
Either the dinosaurs lived at different times, there was more food, or they didn't eat as much, and as ideas to explain how you get so many giants on one chunk of land. Now imagine spending time here, out in the field, wandering up and down hills. How many of you have actually dug up a fossil in a place you'd call Badlands? Put your hands up. A bunch of you. That's great. So you know what I'm talking about here.
Yeah. Anywho, Badlands. And then he's going to talk about faunal endemism, right? Here we go. Probably here. Yeah.
Swamp in Utah back in the Cretaceous. And so this has got us thinking, well, maybe the world was very different back then. Maybe in a hothouse world where it's much warmer and there's no polar ice caps, maybe the greatest diversity of animals and plants isn't at the poles where it might be hotter. Maybe it's at mid-latitudes like Utah.
Anyway, the idea that Scott Sampson and others have, a lot of the people who work in Utah, is this idea of like extreme faunal endemism. That all of these dinosaurs did live at more or less the same time, and what you see highlighted here in this kind of green and yellow, this is like habitable area. So this is like habitat for these animals. A lot of this is like mountains in here, probably not good habitat. So along this narrow strip of land, you've got all of these different species of horned dinosaur living at the same time, but just on their own little like postage stamps up and down the coast. So each one little geographic area has got its own species, all living at the same time. That's one idea. This is what we call faunal endemism, that you've got like extreme local specificity in terms of which dinosaurs are living in which places, and all living at the same time, more or less. This is assuming that the dates that we have for this are correct, and there are researchers who doubt that very much. There are researchers who work on this stuff who say, yeah, the dates that we have for that are wrong. Like, a lot of them are... I'm not in a position to really talk about this, that, like, this is... I don't have as much of a horse in this fight. But there are researchers who are like, yeah, those dates are wrong. These animals lived at different times, and that's why they look different. If you were to take a snapshot... If you were to, you know... take Utah Ceratops gettyi, for instance, down here. From a particular time and place. If you were to go travel back in time to the same time that Utah Ceratops gettyi is from, but go to Montana, you'd probably see Utah Ceratops gettyi in Montana too. Each one of these might be a snapshot of what dinosaurs look like more or less up and down the coast, but since the dates might be fudged a little bit, it looks like they all lived at the same time, even though they didn't. That's one of the ideas. And I want to bring Denver on at some point so we can talk about this. I think that could be potentially really helpful. But this has to do with our Triceratops paper, too, that we'll be getting to in a little bit. Yeah. Anywho. And Dyson Dinosaur, Filippo, we haven't gotten to your paper yet, but I'm excited about it. How are you doing, Filippo? Congrats on the new iguanodont. I'm excited about this. Anywho, Fastfly had a question earlier. What would be an example of modern animals on both ends of the spectrum of food efficiency? Oh, goodness. On one side, you might have... Let's look at two different reptiles, for instance. Think about a saltwater crocodile. A big salty like this. Might need to eat a good meal about once every few months or something in order to stay healthy. They might eat a lot during that time, but they don't need to eat very often. Compare that to the smallest dinosaur that's ever lived. As far as we know. The bee hummingbird, Melissuga helenae. The bee hummingbird, along with other members of the hummingbird group, they need to eat like every few minutes. They could starve to death in a matter of hours if they don't get enough calories in them. They've got an extraordinarily fast metabolism. So crocodiles, pretty slow metabolism for the most part. They can go a long time without eating. Hummingbirds need to eat all the time, and they can eat multiple times their body weight in a single day. That would be the equivalent of you eating like a wheelbarrow full of, you know, McDonald's Big Macs. Or more. Maybe you're eating a Honda Civic trunks full of the Big Macs every day. That would be eating like a hummingbird. If you're eating like a saltwater crocodile, it's maybe you eat an extra large pizza once every couple weeks. Or something like that. And you eat it all at once. Yeah, see what I mean? Yeah. And Science Stream says, yeah, Tuatara need food just once a year? Is that true? Once a year? That's crazy. Very cool. Yeah, again, an animal with very slow metabolism. Yeah. Anywho, let's get into speciation here. And let's talk about how different species can diverge over time. And Petrodactylus says, one of my pet snakes is currently going through a hunger strike. And despite not eating for a couple months, they look totally fine. Yeah. Yeah, those modern reptiles like that, they can go a long, long time in between eating. Anyhow.
So if you've seen our videos before, you may know that one of us is a cat person. Well, the other one of us is a dog person. And when we were younger, we used to wonder, wouldn't it be cool to have one animal that is half dog and half cat? A dog cat? There was a cartoon we used to watch as a kid about that, although because of our TV reception issues, it never came in very clear. Hence our childhood of instead watching nature shows. As cool as a half-cat, half-dog animal would likely be, we need to understand that cats and dogs are different species. So what is a species?
Very different.
Well, organisms that are in the same species can interbreed, and their
Well, again, that's the biological species concept, is that they can interbreed.
offspring can reproduce.
So this is kind of an oversimplification, but we're running with it. It's fine.
That means the huge variety of domesticated dog breeds, they're all the same species, even though they can look very different. Same with domesticated cats. All the different cat breeds are still the same species. You can watch our classification video to learn about the hierarchy levels and taxonomy, but in this
So what's funny is that, like, out of all these, the only one that's really, like, real is species, and even that has got fuzzy areas. Like, if you're comparing a family of one group of animals to a family of another group of animals, or a family of plants, it's like you're not even talking about the same thing. These are all kind of like terms of convenience here. The only one that's actually real in a biological sense is species, and even that is wishy-washy.
this video, we're just going to focus on the level of species itself. Now, can two different species breed and have offspring? Yes. For example, let's consider the magnificent zonkey. Yes, it's a thing. It's a hybrid, actually, a cross between two different species, a donkey and a zebra. Pretty rare, but it can happen.
And Walking Stick Library says a Chihuahua female and a Great Dane dog would have a hard time producing a litter. Sure, but it could still be achieved artificially, even if mechanically it doesn't work super well.
They typically are going to be sterile, though. So even though the donkey and the zebra had the baby zonkey, that zonkey will not be fertile. Donkeys and zebras are different species, so this fits into that species rule. Speciation, which means the development of a new species, can occur when populations are reproductively isolated in some form. Why? Well, first, check out our natural selection video, which talks about natural selection as a mechanism
really good video,
of
by the way.
evolution
We've looked at
and
that
how
before,
change
so.
over time can lead to a new species. Our focus right now is to see how isolation can happen in the first place, which can give rise to speciation. If we're going to get a little more fancy, we could talk about two main types of speciation: allopatric speciation and sympatric speciation.
Yeah, so these are both what we call cladogenesis. So this is when you have a speciation event, where you've got a species that is split in twain. You know, something happens to the environment or something happens behaviorally, and You get one population becoming two or more.
And here comes our disclaimer. In our short video clip, we are only giving some examples of isolation and how speciation can occur.
Yeah,
in
just the basic
allopatric
stuff.
speciation, there's a geographic barrier that separates the populations. So while natural selection is acting on these populations, there is also some geographical barrier, like a river or a mountain, that keeps them from being able to interbreed and share the same gene pool.
Yep. So it's... In some situations, it can be as simple as, like, you know, the trees in a given spot all die, and so different beetles that would like to be able to move across, you know, there's a barrier in between. Like, I don't like that area. There's no trees there. And so the population has got a barrier in between, and the two populations start evolving in separate directions, and they become different species. It could be as simple as that. It doesn't have to be something as dramatic as, like, a mountain or a river coming between them. But these are kind of your classic, basic, easy-to-remember examples.
Eventually, over a period of time, there can be change over time in the separated populations, in their separated areas from mechanisms like natural selection or genetic drift. Over time, these populations can have significant genetic differences that may not allow them to interbreed, even if they were brought together. Populations separated geographically can form different species. You might think you would always need a geographic boundary to separate populations, but in sympatric speciation, the speciation...
So sympatric, sim meaning like, it's like symbiosis, same kind of root word, togetherness. You don't have to have separation. They can be in the same spot in the same time, and still you have a population that kind of splits, even though they're living cheek by jowl together. They're no longer reproducing. Here.
Happens in the same area, yet there's something else isolating them. So what is it? Well, it can be a lot of things. We'll talk about just a few of them now. Let's start with prezygotic barriers. That means barriers that occur before you can even make a zygote. A zygote is a fertilized egg, so a prezygotic barrier is not even allowing fertilization to happen.
Yep.
So of the prezygotic barriers, let's start with this first one, behavioral isolation. This is when species can have different behaviors, even very slight differences, that can isolate them. For example, birds having different songs. Some only have a very slight difference, but this can prevent the males from attracting females of other populations.
Yep.
And these birds can look very similar. Appearances are deceiving. One of the common biology examples is the eastern and western meadowlark.
Yeah, the western meadowlark here happens to be the state bird for like 6 different states, including, I think, Wyoming and Montana. I think Kansas and Nebraska also, maybe. It's a number of different states that have the western meadowlark as their state bird. The eastern meadowlark looks very, very similar, but they don't interbreed. Sometimes they even overlap in range, as I understand it, but they don't interbreed. Does that mean that bird songs are genetic? To a certain extent, NC Corretto, yes. Yeah. There's probably a genetic component to that. It's not just learned behavior. It's something that's probably also instinctual. It's like, that's just the way that these birds are wired to sing in a different way.
Surprisingly, you can find them in the same area. They look so similar, but they are isolated by their behavior. Mates are attracted with a different song.
Yep.
Temporal.
And so songs like that are so important to these birds too, that having slightly different songs will actually be a reproductive barrier. Well, like, they just won't hang out together. Males and females will not spend time together if they're singing different kinds of songs. And so that's a way that you can get speciation, which is really cool.
Temporal isolation, species can breed at different seasons, years, even different times of the day. They may look very similar, but if they don't have the same breeding season, then you're going to have an isolation.
Yep.
Habitat isolation. See, even assuming that organisms live in the same area, that doesn't mean their habitats are exactly the same. You could have 2 species of amphibians living in the general same area, but if one prefers an aquatic environment and one prefers a terrestrial environment, that will be habitat isolation. Now, you can have post-zygotic barriers too.
Yep.
That means that mating and fertilization actually occurred because you have the zygote, a fertilized egg, but there's some barrier that separates the species even still. Remember our zonkey example? Well, that's a perfect example because the offspring is not able to reproduce. That's one barrier that separates donkeys and zebras. Sometimes offspring that are produced between two different species are very weak and they do not survive long. And sometimes, if species interbreed, the offspring is not able to develop, even in very early embryonic stages, because
something goes wrong there. Like, there's some sort of like interruption in the process, something that just isn't quite right, and then the embryo fails.
There's a genetic incompatibility. All of these are post-zygotic barriers that can happen in the same environment. Now, in our short video, we want to point out 3 things. First, this is just a very few set of examples of isolations that can lead to speciation. We encourage you to explore the huge list of other isolation types that can lead to speciation.
Cool stuff, yeah.
Second, species can be impacted by more than one type of isolation.
Yep.
And third, please understand that isolation itself is not the mechanism for the actual change over time. Change over time, which can occur in gene pools of populations, can be due to mechanisms like genetic drift or natural selection.
Or sexual selection, too.
For example, let's take the case of natural selection. Remember that variety naturally exists in the populations.
And that's true. Like, this is, I think, one thing that a lot of people in the general public don't really understand very well. Kind of the basis of natural selection and sexual selection, and thus the basis of evolution, is individual variation. Everybody is unique. You, watching right now, are unique from your siblings, from your parents, from other people who are related to you. You've got your own completely unique set of genes, set of, like, your anatomy is going to be slightly different. You are truly unique and special in that sense. Every organism is. Even, like, exact clones, even identical twins, they've still got slightly different experiences, slightly different ways that their bodies have developed, even if they start off with the same exact genetic material. That uniqueness there is what makes evolution possible. If different organisms weren't different, even in the same species, if they weren't different, then you wouldn't get change, you know? It's those slight differences that get compounded over time. That's kind of what evolution is. I'm grossly oversimplifying here, but yeah.
However, genes in a gene pool that results in high fitness, meaning more offspring.
And that's not what high fitness actually means. This is like a really common mistake in paleontology and biology also. Fitness and fecundity are not the same thing. They're not. But anyway, that's a rant for another time.
Can increase in frequency of the population, which can cause the population to change over time. Isolation is what separates the gene pools of species, so the mechanism acting on the populations is acting on them separately.
There we go.
Well, that's it for the Amoeba Sisters.
Anyway, good stuff. I'll give you a link to this video right here. So that's how reproductive isolation, whether it's allopatric or sympatric, can cause populations to split into different species. And that's all part of what we call cladogenesis. So I'm trying to find you an example, like a nice example diagram of this. There we go. That'll work. Yeah. It's even got dinosaurs as an example. Beautiful. So the way that most paleontologists are used to thinking about evolutionary change is via cladogenesis. This idea that when a population, well, like when you get a new morphotype in the fossil record, you get a new looking critter, it looks different, it's got to be a new species, right? There's an assumption that, oh shoot, there had to have been a split here somewhere, and that's how you get these new forms. This is how you get different species. It should be speciation, not specification. No, that's incorrect. Ignore it. This is how we get this magnificent tree of life that we have. like the incredible diversity of life on Earth, with over 2 million species just represented on this diagram here. It's way more than that in reality. You know, all the way to us. This enormous grand tree of life here. All of these different species are the result of splits that happened. All of the species that are around today are because you had an ancestor, like here the ancestor of the African apes about 8 million years ago, that split into different species. You've got the gorillas, you've got humans, you've got chimps. That's because you had speciation occurring, cladogenesis, like you see here. But that's not the only way that evolution works. Things are always changing over time, generation to generation. If a species isn't evolving, then it's extinct. Each generation is always a little bit different than the generation before. All the individuals are going to be different, and those, like, kind of average morphotypes are going to shift over time too. Evolution is always happening. If you don't get something that happens to split a population, then that normal evolution, just kind of in the background, happening all the time, gradually, we call that anagenesis. And so if you have a population of organisms that doesn't have something happen to it that makes it split, then you get anagenesis. Anagenesis is the default. This is how things will normally go outside of often like another kind of influence. It's kind of like Denver Fowler always used to say, cladogenesis is just anagenesis with splitting. Does that make sense? Yeah. It's, I know a lot of paleontologists are really kind of scared of this idea of anagenesis. Oh, how can we ever observe that in the fossil record? But it is the default. Especially with organisms like dinosaurs, which are probably not very prone to speciating. They're pretty mobile animals. They probably traveled a lot during their lifetimes. It's probably difficult to get them to reproductively isolate into different populations. Denver would always say when we'd be talking about this in the field, he's like, I think cladogenesis is magic. It's rare and special, and when it does happen, it's out of the ordinary. The default evolutionary pattern for dinosaurs might be something closer to anagenesis most of the time, unless something weird happens where you get populations that split, but he doesn't think that's very common. And now, finally, we can get into the Triceratops paper here. Because there's this idea again, published back in 2014 in the journal PNAS, Proceedings of the National Academy of Sciences. Again, if they didn't want us to call it that, they should have given it a different acronym. By looking at literally hundreds of Triceratops specimens and picking out only the ones that have stratigraphic context to them, picking out only the ones where we know exactly where they're from in the rock record, and then lining them up where they should be in the rock record like this, stack them all up, and shoot, there seems to be a gradual change over time here. From small nose horns at the bottom of the Hell Creek to large nose horns at the top of the Hell Creek. Doesn't seem to be a splitting event happening anywhere. The more specimens that we have, and this is a sample size which is unprecedented among dinosaurs. This is the only time we've ever actually been able to look at this. The only time when we've had enough specimens of a particular kind of dinosaur to actually line them all up, put them in stratigraphic context, see what patterns emerge. It's the only time we've ever been able to do this. For Triceratops, the pattern that emerges seems to be anagenesis. Gradual change over time without splitting events. So yeah, Axeman makes a really good point here too. Cladistics is used to track cladogenesis. Is there a process to track and define speciation through anagenesis? That's the thing, Axeman, is that anagenesis is not speciation. It's not one species splitting into two. That diagram here was wrong. Anagenesis is not speciation without splitting. It's not speciation, not really. It's one population changing over time. And so if you take a bunch of Triceratops specimens and you build a cladogram out of them, it's gonna put them on different branches. That's just how cladograms work. And so I think because cladistics is such a widely used method within paleontology nowadays, Denver could talk about this more eloquently and with greater authority than I could, but I'm here right now and so I'm explaining it to you. A lot of paleontologists assume that any change at all that happens in the fossil record, it kind of almost has to be cladogenesis, has to be speciation, has to be splitting. And it's an easy assumption to make. If you only have two specimens, then shoot. Yeah, they must be different branches, right? Must have been a split in those lineages. That's why they look different. It's only when you collect literally hundreds of specimens and put them all into their proper stratigraphic context like this, line them all up according to how old or young they are, that you can start to see those gray areas, those in-betweens, that smooth gradation from one morphotype into another. I think it's interesting that the only time this has ever been done for a dinosaur, it yields a pattern that looks for all the world like anagenesis. You know? So yeah. And Axeman says, how would we describe the early animals of a species versus late versions of the label of a species? You could label them according to their time, or their specimen number. So here you see, each one of these is a different specimen number. MOR stands for Museum of the Rockies. UCMP stands for University of California Museum of Paleontology. It's down the road from me here in Berkeley. Each one of these is a different specimen number. Different specimen, different individual animal. And so, at a certain point, genus and species doesn't really cut it anymore. If you gotta be specific, talk about the specimen number, you know? But yeah. Yeah. Does that make sense? Again, if you really want to understand this in a way that goes beyond the basic level, sometimes you gotta go more in depth like that. You gotta get into the weeds, you know? Anywho, this is a really cool paper. I think one of the most important papers published on dinosaurs within the last few decades. This is from 2014. Here's a link to it right here. It is open access. You can read it yourself. There is no paywall.
Access granted.
But one of the critiques of this paper in the past, researchers have said, well, you're only looking at the Hell Creek Formation in Montana. Like, geographically, you're very restricted. So maybe Triceratops horridus, down here with the small nose horn from the lower Hell Creek, maybe it doesn't actually go away. Maybe it doesn't evolve into Triceratops prorsus. Maybe it's just living elsewhere in a different basin. Maybe the range of that species just changed. And then in this basin, in the Hell Creek of Montana, maybe Triceratops prorsus just migrated in from elsewhere. And it replaced Triceratops horridus in this basin, in this area. And maybe that's what explains this. So the way to test that is to look at these dinosaurs from a different basin, from a different place, but from the same time. And so with this new paper, that has happened. And it's pretty exciting, if you ask me. Take a look at this. The Canadian fossil record supports anagenesis in Triceratops. Really exciting stuff. This just came out today, as far as I know. And It's so hot, new, and fresh that we don't even have like a formatted version of the article yet. This is like a journal preprint, so it's not going to be super pretty. But we have the text and we have the figures. There it is. So yeah. So they decided, well, is it actually anagenesis? Is this actually Triceratops horridus evolving into Triceratops prorsus over time? Or are these different species that one just happened to be in this basin at this time and then maybe they migrated out or got replaced by a different species or whatever? One way to test that is to go to a different basin, go to a different place from the same time, and see what Triceratops exist there. Again, science is about testing ideas. It's not about just making assumptions or having hunches or arguing things in a way that's convincing. You have to actually test ideas using evidence. And so, in testing the anagenesis hypothesis, they said, well, if we look at Triceratops from Canada and figure out how old they are, is that consistent with what the anagenesis hypothesis would put forth? Or is it contradicted? Let's take a look. So the abstract here is like a short summary of the paper. We'll look at it real quick. Evolution of the ceratopsid, horned dinosaur Triceratops, has been hypothesized to have proceeded anagenetically, without splitting, with the geologically older Triceratops horridus having directly given rise to the younger Triceratops prorsus. This evolutionary scenario is based primarily on the upper Maastrichtian fossil record of the Hell Creek Formation in Montana. So that was one flaw with that study, is that it's limited. The Canadian fossil record affords an opportunity to test this hypothesis beyond the geographic bounds where it was originally developed. The Canadian strata, the Lower Scallard Formation of Alberta and the Frenchman Formation of Saskatchewan in Canada, are roughly contemporaneous, so they're from about the same time, with the upper one-third of the Hell Creek Formation, where Triceratops prorsus is found. So on the anagenesis hypothesis, the Canadian strata should, therefore, uniquely contain that species. So basically, so here you've got lower, middle, and upper Hell Creek. Those strata up in Canada correspond to only the upper. And so, if they can find one of these guys from the upper Cretaceous of Canada, that would neatly falsify the anagenesis hypothesis. They could say, well, this is not evolution over time. It's just, you've got different species living in different places. So they were looking hard for any Triceratops horridus from the upper Hell Creek equivalent strata in Canada. Could they find any, though? Where's that paper? Here it is. So they did an exhaustive survey of Canadian Triceratops. They looked at all the specimens they could find from Canada. And then, supported by cladistic and ordination analyses, they confirmed the presence of a single species, Triceratops prorsus, in Canada, yielding robust support for the anagenesis hypothesis conceived for the genus. So there you go. A hypothesis tested using evidence, and it has survived that test. Pretty cool. Pretty cool. And what's this, Claire? I like this. There you go. This is much better, Claire. Thank you. Here, I'm going to save this. Yeah. It should be growing apart, though, right? I appreciate you whipping this together, Claire. Thank you, thank you. Yeah. Excellent. Yeah. This is how you can tell it's not AI generated. A human being made this. Thank you, Claire.
Research has succeeded with their 3 co-explorers.
The search for dinosaur bones begins in a place like this.
Mick Canary, thank you for the raid. Welcome to Paleontologizing. It's wonderful to have you here. How was your stream? I hope it was really good. How are things? We're talking about evolution in dinosaurs here. remember Triceratops. I know this isn't Triceratops. We're using a different diagram here. But anagenesis, and there we go, yeah, it's not really speciation, but we think that Triceratops are slowly evolving over time. At least that's been the hypothesis put forward, like in this 2014 paper, is that if you look at enough Triceratops specimens, over time they start to change like this. The nose horns get bigger and bigger and bigger as you move across the hundreds and thousands or even millions of years. But this is only in Montana. Is this true in other places as well, or is this like a weird geographic thing? It's only in Montana. These authors, including one of the same authors there, John Scannella, they tested this hypothesis by looking at Canadian Triceratops, and they see the same exact pattern, it seems. Very cool. And stream was good. Drawing Spinosaurus today. Very nice, McCanary. Yeah. Good to have you here. Thank you again for the raid. I hope your Spinosaurus illustration went well. If you have a link to that, I'd love to see it, if you wouldn't mind. You can share a link. I work on Spinosaurs. Yeah. Let's see. But I'm really excited about this paper. I get really jazzed about anagenesis in dinosaurs, so this is pretty darn neat. Yeah. Hypothesis testing. Let's just look at some of their figures here. Again, this is still an unformatted manuscript, so it's not going to be very pretty. But they do have figures down here at the bottom. Here we go. So yeah, different Triceratops specimens from across the North American West here. As far south as Colorado and as far north as Alberta. Through Montana and the Dakotas and Wyoming too. Lots of different specimens from different places. But yeah, that's very much a prorsus nasal horn there, and there too. Here's some of the ones from Canada. Brow horns, kind of short and stocky brow horns, like we would expect from Triceratops from the Upper Hell Creek, and it turns out from the equivalent time in Canada, they look largely the same. So here they got some cladograms here, some diagrams showing these, like, where these different specimens fall out according to where the characters are coded. There you go. Nice. There you go. Very exciting. I wish we had a fully formatted manuscript, but we can make do with this for now. This is good stuff. This is good stuff. Yeah. And Axeman says, this seems like very exciting, significant shift in how paleontologists look at specimens. I like to think so. How likely do you think that it is that most people will embrace this based on this paper? Is it the beginning of a huge shift? We'll see. You know? I hope it'll be eye-opening for some folks. But there's a few different there's a few different forces at play that make it unlikely that this will become like the new paradigm. There are some biases that exist, in my opinion, that are preventing a lot of dinosaur paleontologists from thinking along these lines. Part of it is the whole like extreme faunal endemism hypothesis. That still holds a lot of sway, and everybody wants their dinosaurs in their particular area to be unique and special. It's not as fun if you've got the same dinosaurs in Montana that you've got in Alberta, that you've got in Utah, and then in New Mexico. So I think there's a bias against that idea. Likewise, I think there's a bias against the idea that you don't have splitting going on, because if they're not really different species, then you don't really get to name them, you know? And There we go. Again, here's a clip from Jack Horner, my old boss, talking about one of these concepts.
Scientists have egos, and scientists like to name dinosaurs. They like to name anything. Everybody likes to have their own animal that they named. And so, every time they found something that looked a little different, they named it something different. And what happened, of course, is we ended up with a whole bunch of different dinosaurs. In 1975...
Anywho, part of this is that, like, you get different dinosaurs that get named when maybe they shouldn't have, you know? I don't remember how much I talked about this last summer.
Wasn't it a meteor?
They're all meat eaters. Meteor. Take it easy.
Designed by Dave, thank you for the raid. Welcome to Paleontologizing. It's wonderful to have you here. How was your stream? I hope it was real good. John Klopp, rather. John Klopp, hey to you too. Hope you're doing well. Welcome to Paleontologizing. Designed by Dave, I hope your stream was great. Tell me about it if you want to. You're welcome. Some of you might remember this critter that was published last summer. There was a lot of press around it. It was in the New York Times. Lokiceratops. Weird animal in the sense that, look at the asymmetry in its horns. One side looks very different from the other side. Especially when you look up top at those big epis there coming off of the parietal. I'm not convinced this animal should have been given a new name, given that it is very likely within the range of variation in, like, Albertoceratops, which is roughly from the same time in the same place. But it was a commercial specimen. It was sold to a museum in Europe. People naming it. They really wanted to give this thing a new name. I think that was part of the condition of sale, basically. Is like, hey, we're gonna, you buy this thing and, we'll name it. We'll give it a new name. It's kind of a travesty how this thing was dug up in the first place. Like, they botched the excavation. Damaged the specimen during that, commercial stuff. That's how it goes. These, like, private firms. Anywho, yeah. This is an example, I think, of a time when you have individual variation that maybe gets confused for, like, species differences, Especially now that we realize that a lot of these animals within Ceratopsidae look very, very different from one another.
Yeah, okay.
In one specimen has no P2s at all. It has none of those midline horns.
Amelia Bedelia, thank you for the 37 months of support. I really appreciate that, Amelia Bedelia. Thank you. Keeping me here online for that long time. Thank you kindly. So, how do you actually get a sense for how much individual variation there is within a dinosaur population? You've got to have a bunch of different specimens of the same species of dinosaur from the same time in the same place. So, like, an example of that is this place, Pipestone Creek, up in Canada, where this is not the same kind of horned dinosaur. This is, I think, Centrosaurus here. But you had a whole bunch of these dinosaurs. Pretend these are Pachyrhinosaurus. You've got a bunch of Pachyrhinosaurus. They're all crossing this river, and a bunch of them don't make it. Maybe it was after a big rainstorm, and the levels are really high, the water's flowing fast. These animals, some of them get confused and just get, like, knocked around by other ones. Some of them drown. So you get a bunch of them that all live together from the same herd, and they all die in the same place. That's what we've got here at Pipestone Creek, up in Alberta. So here's Emily Bamforth. She's actually one of the authors of this paper we're looking at. Here's her talking about this.
So the back of the frill is there's often horns that project out the side. Different horned dinosaur species do all kinds of weird things with their parietals. So that picture there on the right, that's Styracosaur. So Styracosaurs have these huge, long parietal horns that come off the back of their parietals. So a whole bunch of different species of horned dinosaurs have done all kinds of different things with their parietals. In Pachyrhinosaurus, so that's the kind of the image in the middle. You can see that that's a Pachyrhinosaur looking like kind of head sort of top down at the skull.
That's right.
So you can see the orbital boss there, then the nasal boss, the orbital bosses. Then you can see Pachyrhinosaurs have got basically two horns that stick out the side and two horns that cross over in the middle.
Yeah.
So the two horns that cross over.
So the point is, there's a ton of individual variation in these animals. Since they've got them from the same time in the same place, they've got a bunch of different parietals here. And they all look different, like crazy different, to the point where if you had found these miles apart, you would assume probably that these were different species because they look so different. But they're all from what seems to be Pachyrhinosaurus, all from the same bone bed. These are all animals that lived together and died together. So they're all members of the same species. So what that suggests is that slight differences in the parietals are not good enough to designate new species. So Lokiceratops here probably shouldn't have been named as a new species. Anytime you've got like a single specimen and it's like, oh, it looks different, better name it a new species or new genus. Like, hold your horses. Maybe not so fast here. Unless it's from a new stratigraphic horizon, unless it's from like a new time where we don't have examples yet, then it would be more likely to be a new species. But if it's from a time that we already know about, and it looks just slightly different from dinosaurs that we already know about, maybe we don't name it as a new species, So yeah. Yeah. And Gojira says it's literally wattles, like on galliform birds, but bonier, yeah. These were almost certainly display implements that these animals had. For showing off to each other. Yeah, and for telling each other apart, too. On an individual basis. Does that make sense? Yeah. Hello, sweetie pie. How are you doing? It's good to see you here. It's good to see you here. Here, are you looking for some treats? Is that what you're after right now? Yeah? You gonna push the camera around? My little camera operator. Yeah. Sorry, not little. Sweetie Pie here is a member of the property-owning class. She's actually one of my landlords here. So, she's come here to collect rent. Haven't you, Sweetie Pie? Haven't you? Yeah. Is that why you're here? Is that why you're here? Yeah. Oh. Is this some rent-seeking behavior? Yeah. Oh, Sweetie Pie. Let's get you some treats, huh? What do we got for you? What do we got for you? What's in here? Oh, goodness. Look at all those. What a feast. Good stuff. Here, give me a minute while you work on that. Sweetie Pie. What do you think? Look pretty good? You happy with that? Yeah? Oh, well. So anywho, I hope that makes sense with regard to... We're talking about so many different concepts here. We're talking about variation within a species. We're talking about differences between species. We're talking about speciation, how new species form. We're talking about cladogenesis versus anagenesis. We're talking about dinosaur biogeography and stratigraphy and evolution and talking about like niche partitioning and ontogeny as well. There's so much to discuss. It's interesting stuff, you know? Mick Canary says if only we could get genetic data, but we don't have it. And presumably we'll never have it for dinosaurs because DNA is a very, very fragile molecule. It doesn't stick around for very long. The last of the dinosaurs, except for birds, died out 66 million years ago. The oldest DNA we've found of any organism is something like 1 million years old. So it's like 66 times too recent. Like, DNA is 66 times too fragile for us to be able to find from dinosaurs, it seems. And that's under, like, ideal circumstances that you have DNA preserved. Which fossilization does not normally lend itself to ideal conditions. So anyhow, yeah. Yeah. Anywho, let's look at this right here, your Spinosaurus illustration, Mick Canary. Oh, very nice. Oh, I like that a lot. Yeah, good stuff. Nice Spinosaurus there, too. Yeah, it's difficult to try and reconstruct these guys. I figure they've probably got longer forelimbs than this. I love the terminal rosette you give it there with the teeth and everything. And that crest. I like the eye here, that's really neat. Yeah, interesting stuff. I like that a lot. Yeah, and I like a peaceful Spinosaurus. You don't often see that. Theropod dinosaurs are often portrayed as being, you know, kind of monstrous. They're always like running around, baring their teeth, snarling or fighting, or trying to rip the guts out of another animal. I don't see that here. It's a nice change of pace. I like that. Thanks for sharing. Yeah. Some of you have probably heard rumors about this already, but there's a new kind of Spinosaurid. I heard about this at SVP this year, the Society of Vertebrate Paleontology meeting. There for Sereno's talk about this. But he's got a new Spinosaurid from North Africa with some very interesting headgear. Yeah. I wonder when that's going to come out, but it's surely going to be a big announcement. And I think they've got like a National Geographic documentary that's going to come out at the same time, because there were National Geographic clips that he showed during the talk. So hopefully that helps elucidate a little bit what's going on with Spinosaurus and these other Spinosaurids from the end of the end of the early Cretaceous in North Africa, and Morocco and Niger and Egypt. Yeah. Anyhow, good stuff. Thank you, Mickey Canary, for sharing with us. I appreciate it. It's good stuff. Anywho, in Dyson Dinosaur, you're here just in time for us to look at your paper. So let's do that in just a minute. But here, Sweetie Pie is she's still not satisfied. She demands more treats. More. Satiated. Okay. Come here. There we go. How's that for you? Like that? Start to the airport in 3 hours. Oh boy, Dyson Dinosaur, shoot. Flight goes well. Thanks for spending time with us. It's okay, sweetie pie. You can eat those. Don't get spooked. And you have something going on in your eye right now? Some eye gunk? Let's see. What's going on with those eyes, sweetie pie? Bring him here. What? She does not want to be held right now. Okay. All right, fair enough. She'll be fine. Anywho, yeah. And Governor Frodo says cat has an appetite of a saber tooth. Sometimes, yeah. She really loves those new treats. Here, let's get rid of these tabs here. And, there we go. So this was exciting. Filippo Bertozzo, aka Dyson Dinosaur, who's here in the chat right now, is one of the authors on this new paper. There he is right there. Evidence of large-sized ankylopalexian dinosaurs, Ornithischia iguanodontia, and the Upper Jurassic of Portugal. So I was talking, for some reason, a little bit yesterday about how the Iberian Peninsula is kind of a new frontier in dinosaur paleontology. There's so many new dinosaurs that are coming out of Spain and Portugal. Here is one of those right here, which is pretty exciting. I don't have access to the Journal of Systematic Paleontology, unfortunately. I don't have $64 to drop on a PDF for this. But Filippo very kindly sent me a link to this paper. So let's go ahead and pull that up right here. Good stuff. Yeah, thank you again, Filippo. Let me just say right off the bat, one of the things that I really like about this paper, just having read the abstract real quick, is how, you know, there's not a ton of fossil material for this new animal. And so the team that wrote this paper, I think, did the right thing in not giving it a new name. It's so tempting sometimes to name a new dinosaur based on really fragmentary material, and they withstood that temptation here. They published on it, but didn't name it. And that's the thing, is that sometimes when you find what seems to be a new kind of dinosaur, but you've got very limited material, you don't have a whole skeleton, if you name that dinosaur something new based on very limited material, that name stands a high likelihood of being invalid. Somebody else might find a really good specimen, but it might just be missing the one bone that you had, so you can't compare them to figure out if they're the same critter, and it causes problems, you know? Yeah. And Dyson Dinosaur says, there were good reasons to name a new species, but those were not enough. There you go. And a big paleo salute to you and your team for withstanding that temptation. Because I know it is very tempting. I might be undergoing similar temptation this year, working on a Californian dinosaur. Really cool to name it, but only if the fossils warrant it, you know? So we'll see. Much everything was done by the first author, who is a different Filippo. Filippo Maria Rotatori. I'm not familiar with this Filippo here. Yeah. Probably a number of Portuguese authors here who I'm not really familiar with. But let's take a look at the abstract real quick. This is a short summary of the paper. So I'll walk you through that, chat, and we'll talk about some of the jargon, and I'll try and decode it for you. And if I get anything wrong, Filippo, or if anything's, if I'm not explaining it in the right way, an ideal way, jump in there and correct me. And you've known each other since 2006, the two Filippos? I like that. Yeah. Very cool. So the upper Jurassic beds of the Lusitanian Basin in central Portugal yield diverse dinosaurian fauna.
Do you think dinosaurs are put together correctly? The bones. You're smart. What do you think?
Do a research on that, Oliver.
I never...
Thrylo64, thanks for the follow. It's good to have you here. Lusitanian Basin in central Portugal. Let's see if I can find an image of that. Yeah, the Lusitanian Basin. So is it around Lisbon? Huh. There we go. So it's no longer filled with water, but it once was. Yeah, cool. Okay. Anyway, in central Portugal, it yields a diverse dinosaurian fauna. So lots of different kinds of dinosaur living in this sort of environment back then. Dated to the Kimmeridgian-Tithonian interval. So in the late Jurassic here. Pull up our time scale. So Kimmeridgian-Tithonian goes from, we're saying about 152 million years ago, give or take. Right there. Yeah. So from toward the end of the Jurassic period, before we get into the Cretaceous. Saurischian dinosaurs, these are the lizard-hipped dinosaurs like we were talking about yesterday. Mostly sauropods and theropods. They are overall more abundant than their ornithischian counterparts, more abundant, more common than the beaky plant-eating dinosaurs, in terms of both specimens collected and species recognized. Iguanodontians are so far represented by several different taxa. Iguanodontians are these beaky plant-eating dinosaurs. Tend to be fairly bulky, especially later on. Tenatosaurus, I think, is considered an iguanodontian. This is your iguanodonts, like Iguanocolossus here. This is one of our critters from the Cedar Mountain Formation in Utah. These guys, yeah. The duck-billed dinosaurs are also part of this group. Yeah. At one point, we talked with Karen Poole about what an iguanodontian is, and I don't know if I'm going to be able to find that clip fast enough, but Karen Poole works on this group of dinosaurs also. These guys show up in the Jurassic. Earlier examples of this group are like Amptosaurus, maybe even Dryosaurus. These are iguanodontian dinosaurs. So, yeah. Beaky plant eaters, not a whole lot of bells and whistles on them, but they do, in the Cretaceous, start to develop these thumb spikes. These spikes on their thumbs that they would have been able to use as weapons. I think Styracosterna as a group, those are largely characterized by that thumb spike. Yeah. Here we go. Here's only slightly gruesome video from a video game with Iguanodon, namesake of the iguanodonts, using its spiky thumb to defend itself against various meat-eating dinosaurs. Carnotaurus right there. Allosaurus. Bryolophosaurus. Yowza. Yeah. Oof. Carcharodontosaur. Yowza. Yeah. So, you know, those thumb spikes would have been formidable weapons.
How can the study of iguanodontians help you understand kind of the history of life on Earth while these animals are alive?
Thank you, Claire,
They
for
are
posting these links.
prodigious chewers. These particular animals that we're digging up in this quarry, they were probably eating things like pine needles, ferns,
Tree ferns, yeah.
tree ferns,
all that Tempskia that we've been finding in the
yeah,
quarry.
Exactly.
Yeah.
Maybe some cycad kind of things,
Uh-huh.
but like that's what they had to eat. It was tough vegetation.
If we're to look out across this landscape right now, all of these are going to be flowering plants, I think. Might get some pine juniper,
Yeah.
which is a conifer, but like everything else out here is a flowering plant. Everything with flowers, grass is a flowering plant.
Mhm.
Most things that produce fruit are flowering plants nowadays.
Yeah. Yeah.
So it's like,
basically picture anything other than a pine tree or a fern,
yeah.
and it's a flowering plant. You know,
Yeah.
even though you might not picture it with flowers,
Mhm.
it's still gonna fall in that group called
Yeah.
angiosperms, which
Uh-huh.
are the
It-
flowering plants.
It's like 90% of plant species today or something crazy like that.
Yeah. I don't know if you.
Anyway, we're just talking about angiosperms here. We want to get to the iguanodonts.
How can the study of iguanodontians help you understand kind of the history?
Oh, must be this one.
Karen, would you like to introduce yourself?
Hi, I'm Dr. Karen Poole. I study iguanodontian dinosaurs. So I was working at the Utah Raptor Ridge before we even called it that. We had this little kind of iguanodontian thing that we didn't
Okay,
really know
Claire.
what it was, and we were out there working with Jim, and he says, you know, somebody's got to do an iguanodontian phylogeny. Like, we don't know how these things are all related. And at the time, I was sort of like, I don't really want to do that.
You didn't have prior interest in iguanodonts before
Not
that.
really, not
Yeah,
really.
okay.
And then I kind of just ended up working on this thing that we got from the site as my master's thesis. And as I got into it, I was like, we don't know anything about these animals, like in terms of phylogeny. So iguanodon itself was originally named from fossils in England. We know a fair amount about those animals, but there's this whole larger group of iguanodontian dinosaurs. They're not all iguanodontians in my phylogeny, but I think I had like 67 or 68 genera.
Wow.
And,
Wow.
and they're known from every continent. These animals were hugely successful.
Including Antarctica.
Karen, would you
Yeah.
like to introduce yourself?
So iguanodontians, when a lot of these Morrison critters go extinct, when you've got Diplodocus and Ceratosaurus and Apatosaurus, like a lot of your classic Morrison dinosaurs. Morrison Formation dinosaurs. When a lot of these guys go extinct, the stegosaurs, the big sauropods, yeah, the big ol' Apatosaurus there, and Diplodocus, maybe Barosaurus up there, they go extinct at the end of the Jurassic. But see those two little guys right there in the brown? Here we go. These guys here, those are Camptosaurus. They very well might survive the Jurassic Cretaceous boundary, because we've got very similar guys in rocks just above the Morrison, the bottom of the Cedar Mountain Formation. So whatever killed off the sauropods in North America, it might not have touched these guys. They just kept chugging along, kept on evolving. And then at the beginning of the Cretaceous, iguanodonts start to take over. They become a really important component of these ecosystems. They start evolving into big things like iguanodon, and later on into the big duck-bill dinosaurs. And see, Coretta says they look pretty bird-like. What's funny is that these guys are not related to birds closely at all. They're from the other side of the dinosaur family tree. So they've got some similarities. They may have even had little bits of feathering. But as far as dinosaurs go, these guys are not closely related to birds. Yeah. Anywho. And Dyson Dinosaur says, what happens in the transaction between the Jurassic and Cretaceous is very interesting for ornithopods. They're confined to small body sizes beforehand. And after that, they get widespread, grow up into the hadrosaurs, the duck-billed dinosaurs. Early Cretaceous iguanodontians were large and stout. Yeah, they may have been kind of occupying some of the same niches that the big sauropods did prior to that. Yeah. You get critters like Iguanocolossus early on. This is from, like, what, the upper part of the lower Yellowcat Formation, I think? Iguanocolossus is not a small animal, as the name would imply. It's a big one. You know, this is it's a large size animal. This is an illustration from DeviantArt. I love it. Yeah. So it's a big critter. The ones we were digging up in Doling's Bowl don't seem as big, but we don't know if they're full grown. But it seems different from Iguanocolossus in a lot of different ways. So we're probably looking at a different sort of animal. I'm trying to get this set up so you see the scale there. There we go. Iguanocolossus compared to a human businessman. Yeah. Oh yeah, Iguanodon bernasartensis, yeah, is huge. Yeah, this animal gets large. Iguanodon bernasartensis is one of the biggest of the ornithischian dinosaurs. They get pretty big. Yeah. Anywho, and here, let me grab my Iguanodon hand. Be right back. This is a big critter. For reference, here is my hand right here. Here's the same hand on Iguanodon. Right there. Just enormous. Look at that huge thumb spike right there. In life, it would have been covered by a keratinous sheath, would have made it even longer and significantly sharper. But that is a big hand right there on this critter. Very, very big. See that right there too. Oh yeah, it's big. It's a big animal. And Lurdosaurus had even bigger thumbs? Yeah. That critter. What was that animal doing, Lurdosaurus? Is it like leading a hippo-like existence in the water? What's up with Lurdosaurus? Anywho, so iguanodonts. Hopefully I've sold you on the idea of these being interesting animals. They're very important. But where do they come from? What are they like during the Jurassic? I showed you Camptosaurus earlier. Camptosaurus is pretty widespread here in North America, but what's going on across the pond? Let's go to, say, 150 million years ago. There we go. So, Camptosaurus, whom I showed you earlier. There. Camptosaurus. This guy. Camptosaurus is from western North America, the Morrison Formation. This is about what our Earth looked like about 150 million years ago. The continents are just starting to break apart. You know, Pangea is not long for this world. You've got the Atlantic Ocean starting to open up. And over here, in Portugal and Spain, you've got very similar kinds of dinosaurs. It's interesting. They must have been able to move across some land bridges and then get over here. You get a similar, but in some ways different fauna here and here. That brings us to this paper. Yeah, that Monmouth craft could. I know, right? That's not a Anyway, iguanodontians, this group of dinosaurs, are so far represented by the Styracosternin, I think those are the thumb spike guys, that particular clade, Draconix, the Dryasaurid Eusodryosaurus, and the enigmatic Dryomorphin Hesperonyx. Here we aim to highlight the diversity of this clade in the late Jurassic of Portugal. So in this paper, they're trying to point out how many different kinds of iguanodontian there are and how different they are from one another. Presenting evidence for yet another species of Ankylopalexian iguanodontian dinosaur. So, Ankylopalexia, these are guys who've got a fused wrist or something like that, I think? Represented by the specimen SHN-JJS015, which is housed at the Sociedad de Historia Natural Torres Vedras in Portugal, presumably. Detailed comparisons rule out attribution to previously known taxa. So it seems like this is different from other iguanodontians, they're saying. By studying it carefully, they're like, this is new and weird. And phylogenetic analyses, making an evolutionary family tree, that include the specimen, indicate early diverging at this stage. Interesting. Hopefully it's not just a juvenile. Nevertheless, this specimen represents a previously unreported taxon, seems to be a new kind of dinosaur, that highlights greater diversity than previously estimated among the iguanodontians of the late Jurassic. It highlights the importance of Europe in diversification and dispersal events of this clade. So they're saying, this thing looks new, maybe there's more kinds of iguanodontian from this time and place than we previously assumed. And if that's the case, if you've got high diversity of iguanodontians in Portugal in the late Jurassic, this could be a really important area of study for trying to figure out how these creatures first originated, how they diversified, and how they became so important later on in the Cretaceous. A series of smaller isolated femora, so we've got some thigh bones, from the same subbasin as this type specimen, may represent the same taxon, so those thigh bones could be from the same animal, presenting evidence of thriving communities of Ankylopalexians during the Kimmeridgian-Tithonian interval in Portugal. Very cool stuff. So you've got some limb bones there. Was there any histo done on these? You know I'm all about the histo there, Dyson Dinosaur. Yeah. Oh, and the Lusitanian Basin also has continental early Cretaceous deposits, so, oh boy. So, if you look in those rocks and find some early Cretaceous iguanodontians, you can maybe see, if they look really similar, that could mean that they survive across the boundary, which would be really neat. Yeah. And histo is planned? That is excellent to hear. Really glad to hear that, Filippo. Very cool. Very nice. So let's quickly look through the paper here. We do have to do Marsh Madness later on as well, but I think we're making good time so far. Discussion of the geology here. And there we go. So this is still along, I guess this is in coastal Portugal. Okay, so I guess central Portugal meant north to south. Oh, this is cool. Filippo, Jim Kirkland was telling me about this, about some crews that he'd seen in Portugal. They would dig up these late Jurassic dinosaurs during the day, and when it would get too hot, they would just go down to the beach and go for a quick swim in the ocean. Sounds like a lovely way to cool off. Hearing about this when we were working near Moab, Utah, when it was 115 degrees Fahrenheit some days, that sounded awful good. Just being able to dive into the ocean to cool off for a little while. Oh man, that sounds amazing. you ready to vote for Ceratosaurus? Nice, Petrodactylus. We'll see. We'll see. Yeah. And Dyson Dinosaur says Portugal is the best place for field work. You go dig on the coast, enjoy the ocean, finish the day on a bar up on the cliff. The only downside is we are limited by the tide time. Ah. Well, you know, pluses and minuses. That sounds pretty good, though. Sounds pretty good. You got a lot of late Jurassic rock throughout here, too. It's lovely. So here we go. Marienhof Formation. Our critter comes from here. So from like just above the Kimmeridgian-Tithonian boundary, it looks like. Are these this little series of hashes here meant to represent from somewhere here in this time? So like right around the boundary, I guess? Huh. Nice. Very cool. So we've got, from this partial skeleton here, a dorsal vertebra, that's one of the verts from the back, a scapula, shoulder blade, humerus, upper arm bone, femur is the thigh bone, calcaneum is from the foot, ankle rather, and we've got a femur and another femur. Nice. That must be total length, right? Anyhow, very cool. Yeah, and so again, kudos to the authors not naming a new taxon based on rather fragmentary remains. Hopefully they've got more in the hopper. Hopefully they've got more that they're working on now. And maybe with more material they can name it. But I really appreciate that they're not trying to name a new dinosaur based on fragmentary material. Lesser authors wouldn't hesitate to do that. This is it's an indication of quality here, and I appreciate it. Let's take a look at those fossils. We've got a lovely dorsal vert right here, nice centrum, neural canal, transverse processes, pre-zygapophyses, and neural spine right there. There's a front view, side view, nice ventral view right there from the underside. Very cool. And look at that scap. Really nice shoulder blade right here. You seeing this, sweetie pie? You seeing that? Look at that scapula. That's pretty sweet. Look at that. It's a lot bigger than your scapula, you know? Not like, it's not a competition, of course. But, yeah, I can feel your scapulae. They're much smaller. They're much smaller. I feel them right here. Little kitty scapula. It's a lot smaller than this guy, huh? Yeah. Nice, and then we've got... What is this? Proximal end of the scapula. Okay. More scapula here. And then these are broken, but they look like limb bones. Is that a femur? What is this? Scapular blade. Okay. Humerus. Okay, that makes more sense. And that's the femur. Yep. Terminal head. Yeah. Nice. Looks a lot like Camptosaurus in a certain light. Camptosaurus, whose name means bent lizard because the femora have got kind of a bend to them. Yeah. Nice. Another femur there. Yet another femur. Good stuff. Sweetie Pie's like, oh, I like this. You like this? You learning some anatomy here, Sweetie Pie? Yeah. Some osteology. Good stuff. Look at that. And there we go. Now we've got a phylogeny here. Whoop, wrong button. Phylogeny. So our new critter, again, we were talking about, you know, how can we identify these animals if we're not using genus or species names? can just use a specimen number. That works fine too. There it is right there. And it looks like it forms a polytomy with Camptosaurus and Iguanodont. Interesting. So it comes out pretty basally here. Interesting. Oh, this is going to be one of our dinosaurs later. Dryosaurus right here is going to be one of our contestants in Marsh Madness today. And isn't that paraphyletic? No, it's not a... This is not paraphyletic. This is what we call a polytomy. So a polytomy is when you get multiple taxa or multiple specimens that all kind of come out in a bunch like this. So this new critter here, not yet named, is forming a polytomy with Camptosaurus and Iguanodont and all these other guys off the branch over here. Anywho, good stuff. And it's about where we would expect it to be, too, given its age. It'd be really weird if it was allied with Eolambia or Hypacrosaurus or something. Not a chance. So it shows up kind of where we would expect it to be. We've got some weight estimates here based on presumably the circumference or the diameter of the femur. Estimated to be 1,378 kilos in weight. It's going to be about 3,000 pounds. Yeah. Cool stuff. And there is an illustration of what this critter may have looked like, kind of based on Camptosaurus. Very scaly here. Nice. Reconstruction of a large-size ankylopalexian iguanodontian dinosaur interacting with a juvenile in the late Jurassic of Europe by Victor Carvalho. Nice. Oh, and I guess this is a Creative Commons piece. Very cool. Yeah. Good stuff. And ontogenetic trends in the ankylopalexian femora. I'm glad we're talking about ontogeny here. Good stuff. Even though the isolated femora cannot be referred unambiguously to the same taxon as this new critter, the specimen number, we can make some observations on the ontogenetic trends in the group. The differences in size are interpreted here as related to different ontogenetic stages. So again, I'm glad you're taking ontogeny into account rather than just saying, oh look, we've got big species and small species. More parsimonious explanation is probably that these are different growth stages, and I love that that's in here. The overall proportions of the femur shaft are preserved during growth, whereas the fourth trochanter and the extensor groove become progressively more prominent. Not surprisingly, the acquisition of the mature traits is correlated with an increase in size for the most immature stage of approximately 100 kilos in weight, of the fully grown individual of more than a ton. Okay. Very cool stuff. And paleoecological and paleobiological implications. Here's some fun stuff. Here's some discussion style things here in the paper. The evidence presented herein supports the presence of at least one large-sized ankylopalexian iguanodontian, so critters similar to like Camptosaurus, in the upper Kimmeridgian to lowest Tithonian of the Lusitanian Basin, together with Eusthriosaurus, Draconyx, and Hesperonyx. The number of coeval iguanodontians thus rises to 4 forms. So 4 of these iguanodontians all living at the same time in the same place. There are currently no grounds for synonymizing any of these taxa. So could we combine them? Could we say, well, these are probably the same thing? The authors here are saying, there's no reason to think that yet. Although more complete specimens may lead to future taxonomic revisions. So when we find a complete skeleton of any of these critters, maybe you'll have different distinct traits from these different species that are actually in the same skeleton. Maybe that would warrant lumping them together and saying, oh shoot, these are the same species. We'll see. I like that line is in there. The presence of coeval, closely related ornithopod taxa was common in early Cretaceous ecosystems, such as those recorded in the Wealden group of the UK, the Bernissart mine of Belgium, and the Maestrazgo basin of eastern Spain, as well as in the late Cretaceous ecosystems of North America, Europe, and Asia. However, it has not previously been reported in the late Jurassic ecosystems of Europe. If the taxonomic interpretations suggested in the study stand, so if this turns out to be a new critter and we've got a bunch of different iguanodont genes from the same time and same place, this would indicate a very complex system of niche partitioning. So these different species each doing slightly different jobs in the ecosystem, each maybe eating something different or living in a slightly different part of the habitat or something like that. Ornithopods attained high diversity and a low disparity bow plan.
Sign of disgrace or failure. In fact, in a world full of changing environments and occasional catastrophe, all species eventually become extinct.
Legit Salvage, thank you for the 7 months of support. I really appreciate that. Thank you, thank you. All right, let's get back to this. Yeah, ornithopods attain high diversity with a low disparity bow plan. So a lot of these guys can look superficially very similar, and yet they can do different jobs in the ecosystem, it seems like. This defining condition of the clade was present as early as the late Jurassic. It is also the first time that material from juvenile Ankylopalexians that are likely to have shared the same landscape as adults, but formally described in the Lusitanian Basin. Very cool. This is really neat stuff. I like this a lot, Filippo. Thank you so much for sending me the PDF. Congrats on the new paper. Exciting stuff. Very, very cool. Again, if anybody would like to read this, you might need to get journal access, but because it is unfortunately paywalled. But there's a link to it. If you want to go to your local university library, you could probably get a copy right there. Good stuff. Good stuff. And open out. No, raids are not turned off. Huh. Maybe Twitch is having a glitch right now or something, but I'm sorry that's not working open out. It's good to see you. Hello, hello. Yeah. We do have a limit on raids where if a channel tries to raid in with fewer than 3 viewers, I think it doesn't work. Just because I used to get like a dozen raids every single day, sometimes 2 or 3 from the same channel, like trying to raid in with one person, and it's just a little too distracting. So, yeah. Anywho. And Governor Frado says, how did they get so big eating grass? They didn't eat grass, Governor Frado. Frodo. Grasses didn't exist at the time. Grasses wouldn't evolve until pretty much until after the extinction of the dinosaurs. And these guys weren't particularly big. They're certainly a lot smaller than the biggest dinosaurs of the time. Yeah. Some of their counterparts, like for instance Apatosaurus or Diplodocus or Barosaurus, they got much larger. And these guys ate plants, not grass, but probably ferns, horsetails, club mosses, maybe leaves from trees, maybe pine needles, maybe cycads, things like that. But yeah, some of these guys got truly enormous. The biggest animals that have ever walked our planet were herbivores, plant eaters. And the reason they were able to get so big is a combination of different things. But one of them is just being able to take in massive quantities of food very quickly without chewing. Because like we see here with our Diplodocus skull, that's the smell of the dippy specimen, or this juvenile Diplodocus skull right here, they've only got teeth at the front of their mouth. They didn't chew. Those teeth are just for biting, just for nipping vegetation. And, yeah, These guys may have just been feeding at ground level, eating ferns, horsetails, club mosses, things like that. Or maybe they did browse from the tops of trees. I've heard arguments that go either way. But, yeah, one of the ways that they're able to get so big is just by consuming massive quantities of food very quickly. So just bite and swallow, bite and swallow. None of this wasting time chewing stuff that other creatures do. These guys were all about efficiency. And that really long neck on a lot of these sauropods would have allowed them to expand their, what we call feeding envelope. So they could just stand in one place and sweep that neck across a wide arc and be able to gobble up all kinds of plants without having to actually take any steps. So they're consuming tons and tons of calories without burning very many calories. So, but those calories could go toward growth rather than moving around too much. If that makes sense. Yeah. Their teeth are like rakes, says Petrodactylus. In a way, yeah. Yeah. Cool stuff. And Axeman says, it seems like the biggest carnivores are always smaller than the biggest herbivores at a given point in history. I don't know if that's true. I guess it depends what you mean by carnivore. Like, some of the biggest carnivores around today might be rorqual whales. They are far, far, far larger than their prey, whether it's krill or fishes that they're catching. Yeah. Are they carnivores? I guess it depends on your definition. Yeah. And Gust K 2814, thank you for the follow. Welcome, welcome. Yeah. So yeah. So, but at least in dinosaur-dominated ecosystems, the prey are usually bigger than the predators. Even with gigantic predators like I don't know. Let's think about some of the big carcharodontosaurs like Mapusaurus here. You know, that is a big critter. Still smaller than their prey, potentially. If these guys are indeed going after big titanosaurs, things like, I forget which formation Mapusaurus is from, but another Argentine dinosaur that's really, really big is Patagotitan, which is far larger than the meat eaters were. Much, 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 much larger. So yeah, it's interesting. Yeah. And Governor Frodo says that's insane to hear that grasses didn't evolve until after the dinosaurs went extinct. Yeah. Did they eat fruits then? These guys, I'm sure they wouldn't turn down some fruit if they found it. But that's probably not the bulk of their diet. The bulk of their diet, the thing they're primarily eating, is probably ferns, maybe conifers. I'll show you there we go. Here's a neat figure I actually helped with. When Kerry Woodruff was publishing this, I gave him some Photoshop advice here. Back when we both worked in Montana. So yeah, ground cover like ferns was abundant, ubiquitous. Animals like this is Apatosaurus here, I think. They could basically just stand in one spot, sweep that neck across in a wide arc, gobble up all those plants, consume all those calories, and then just take one or two steps and then start it over again. Really efficient way of feeding. A lot of the fruits that you think of today, whether they're like apples or bananas or berries or whatever, a lot of these wouldn't have existed during the time of the dinosaurs. There would have been some plants that produced various kinds of fruit, But most of those plants that you're thinking of are what we call angiosperms, flowering plants. And flowering plants didn't exist when dinosaurs like Apatosaurus were walking around. The angiosperms, the flowering plants, only really come into existence in like the early Cretaceous, about halfway through the age of dinosaurs. And I think we've got a clip there here, don't we? Yes. Oh, pterosaur here. And then getting back to our iguanodonts. Love the music in this too. So this is after a lot of the big sauropod dinosaurs go extinct. These guys kind of take over. And Dr. Irrefutable says, did they outcompete the sauropods? We're not sure, Dr. Irrefutable. It's a good question. That's the thing, is that before we really had a good sense of the time from the Jurassic into the Cretaceous, we thought there was a big missing time gap there. So it's like, well, shoot, anything could have happened in there. Maybe the iguanodonts did outcompete the Diplodocids, and that's why they went extinct or something. But now that we've got much better fossils, we've got a much better sense of how things actually went down because of work in the Cedar Mountain Formation, work done by people like Jim Kirkland. It seems like that transition from Jurassic to Cretaceous is much more abrupt. And it's just like, it almost seems like these sauropods just one day go extinct. And Camptosaurus and Eudodon, they may have survived and then given rise to critters like Iguanodon, potentially. Or Diplodocus, or whoever these guys are called nowadays. So yeah, it might be because of an asteroid strike. There's new evidence coming out about that. Should be published pretty soon, I hope. Yeah. The Moroqueng impact. Yeah. This may have spelled the doom for dinosaurs like Diplodocus, Apatosaurus, etc. This was what Jim's talk was about at SVP this year, at the Society of Vertebrate Paleontology meeting. Yeah, this could have been a major extinction event about halfway through the age of dinosaurs that caused this turnover and allowed iguanodonts to take over where sauropods were once dominant. We don't really know. So yeah. Anyhow. Oh, and I'll get to your question in a minute, Executive Storm. Here we go. We get rain. They love it. So here we go. but not iguanodontians. Yeah. Yeah, they chew. Here we go. First flowers. Yeah. Yeah. Good stuff. Anyhow, it wasn't until basically halfway through the age of dinosaurs that flowering plants first evolved. So dinosaurs first evolved probably about here in like the Ladinian stage of the late part of the Middle Triassic. And then dinosaurs take over the Earth at the beginning of the Jurassic. They become ubiquitous. They become the dominant animals on land. All through the Jurassic, and then all through the Cretaceous until they go extinct about 66 million years ago. Almost exactly 66 million years ago. Dinosaurs go extinct except for a handful of birds. It was, I think, about here that the first flowering plants evolve. Hodorivian? Could be Valanginian, I'm not sure. But anyway, flowering plants only show up about there, so about halfway through the age of the dinosaurs, you get flowering plant, even later than that, the first flowering plants. Oh yeah. Yeah. Anyhow, Executive Storm says, why can't platypus, considering it has a bill and lay eggs, be a dinosaur? Could it have been an older dinosaur with 4 legs, lived through the Big Impact? No, because it evolved from mammal ancestors, Executive Storm. So the whole way that we as scientists classify living things is based on their evolution, based on who they evolved from. Ancestry is what matters. So I love this little diagram because it shows in a really simple way what is a dinosaur and what isn't. Dinosaurs, by definition, are creatures that evolved from that ancestral dinosaur about 240 million years ago, give or take. So if you evolved from that first dinosaur species, then you are a dinosaur. If you did not evolve from that first species, like for instance the mammals over here, then you are not a dinosaur. Does that make sense? So platypus evolved from earlier mammals that laid eggs. Egg laying used to be really, really common among mammals during the age of dinosaurs. As far as I understand it, most mammal species laid eggs during the age of dinosaurs. And most of those egg-laying mammals went extinct at the same time that the dinosaurs did. They didn't make it across the KPG boundary. They died out. Some of them may have made it into the Cenozoic. Things like multituberculates, they may have laid eggs. They go extinct at the end of the Eocene. But yeah, so egg laying does not a dinosaur make. Again, I really want to emphasize this point because I feel like, well, shoot, I learned this in elementary school, and a lot of you probably did too. That, oh, the way that we classify different animals is based on just a few key traits. If it lays eggs, then it's not a mammal. You know, if it's warm-blooded, then it's not a reptile. But these things, yeah. Yeah, here we go. Yeah, you probably learned some version of this. Vertebrate animals. 5 different classes: fish, amphibians, reptiles, birds, and mammals. You know, this is for kids, so it's, yeah. Yeah. This is actually much better than it could be. But the idea that it doesn't get across is that the way that we classify these living things is not based on these traits. These traits are all interesting clues, but that's not what makes these mammals or birds or fish. What makes them that is their ancestry, what they evolved from. That's how we actually make sense of that. All of this is just window dressing. It can be clues as to their ancestry, but the ancestry is what's important. So what this doesn't get across is that birds are actually a kind of reptile. And reptiles, in turn, are a kind of fish. Mammals are also a kind of fish, and so are amphibians. Fish encompasses this whole group because every one of these different groups evolved from fish. Birds evolved from dinosaurs, which are a kind of reptile. So birds are reptiles. Birds are dinosaurs. Dinosaurs are reptiles. Reptiles are a kind of fish. Does that make sense? This is an oversimplified version of things that really doesn't give people a deep understanding of what these animals actually are and where they come from, you know? It's the most surface level kind of understanding, and yeah. And Governor Trudeau says mammals laying eggs is unreal. No, that used to be the default. Like that is the ancestral state of mammals, is to lay eggs. Special groups of mammals evolved away from that. We call the Therian mammals. I'll show you. Mammals in here. Here we go. We've got our mammals. And the basal most of those, the earliest diverging, are what we call monotremes. All these guys lay eggs, and they're still around today. The platypus and the echidna, these are mammals that lay eggs. It used to be that most mammals laid eggs, at least as I understand it. We don't have a great understanding of like reproductive strategies in Mesozoic mammals, but I think the general consensus is that most of them probably did still lay eggs. But then a few special groups evolved, what we call the Therian mammals. This is composed today of the marsupials and the placentals. They evolved the ability to give birth to live young. So basically the egg and everything was internal, and eventually they just kind of like did away with the shell and everything and just give birth to live young. These guys were in the minority during the Mesozoic, but this is the group, the Therian mammals, that survived the best during that whole extinction event, and that's why they are the most widespread. I'm oversimplifying here. There was a lot of competition going on during the Mesozoic as well, but for the sake of argument today, I'm going to say, for the sake of simplicity today, I'm going to say that this was the big filter. Is at the end of the Cretaceous, you get the extinction of like 80% of species on Earth, give or take. Including about 90% of the mammal species died out at that time. It's nuts. Mammals almost were completely wiped out by that asteroid. And all that subsequent environmental devastation. Same with birds. It's like 94% of bird species died out then too. And so this is like it's a big, what we call bottleneck here. So you've got a lot of species and then it narrows to a bottleneck and only a few survive. And so that's where most of the egg-laying mammals went, as I understand it. That makes sense? Yeah. Anyhow. Yeah. So yeah. Yeah, good stuff. Where were we? I don't even remember. That's okay. Let's get rid of some of these tabs. Congrats to Dyson Dinosaur and co-authors on getting this published. Good stuff. Very exciting. Oh, and Minnie is home from the vet and did great? That is excellent to hear, Lordy. Holy cow, can we get some mini pie emotes going in the chat? Good for her. She won't be visiting stream, though. She's in isolation for the rest of the day. Okay, gotcha. She's got to go through decontamination. Nice. So yeah, I'm sure we'll see her tomorrow. She'll be here probably not too long after the stream starts. Good stuff. Mini pie. I'm glad she did well. Oh, Lordy, is there a tooth for me? I heard that Mini Pie might be having a tooth extracted today. And I asked the vet tech, like, hey, if you're gonna be extracting any of her teeth, can I keep them? I think it'd be really cool. Did she have to have any teeth extracted? Let me know, Lordy. Because, that would be neat. Teeth that were removed crumbled because they were mostly resorbed already. Okay, gotcha. Okay, that's fair. No teeth for you? Shoot. Oh well. I'm glad Minnie had a good experience at the vet today. I'm glad it went well. Yeah. Anyhow. Yeah. She'll feel better soon, yeah. Put them in a necklace. Very cool. I was gonna do the same thing, pet necklace, yeah. Good stuff. Oh, before I forget, let's see if we've got any news about St. George. Oh, here we go. KJZZ.com. That is new. And this one was about me. Partly, at least. Okay. Yeah.
Dinosaur Discovery Site is a fossil dig site where crews are working on a deadline. The city of St. George is expected to begin construction on a new power substation in May, making the fossils there unattainable. So crews from across the U.S. and as far away as England are trying to pull as much as they can from the ground before then. Paleontologist and science communicator Danny Aduza traveled to Utah from Oakland, California to support these efforts by live streaming on his Twitch channel, Paleontologizing,
and we'll be going back there hopefully in less than 2 weeks.
I heard from the state paleontologist here in Utah, Jim Kirkland. Wonders you have right in your own backyard.
What's being discovered there? Read how to volunteer for the fossil dig and what's being discovered there. Read the full story online. This is Alicia Lundgren reporting for St. George News, your #1 source for local news.
Oh yeah, good stuff. There's a link there in the chat for you. So this is from a few days ago, but this is brand new as of yesterday. Paleontologists race to excavate fossils before construction at new substation sites.
Great story. This morning we're launching a new series called Uniquely Southern Utah, spotlighting the people, places, and issues that make this region unlike anywhere else in the state. And we're starting with a story that quite literally digs into that idea.
A site rich with prehistoric fossils is now the future home of a new power substation. The city of St. George says it is a balancing act, updating critical infrastructure while preserving the history beneath our feet.
Well, for paleontologists, it's a race against time. We have our Southern Utah reporter, Liv Kelleher, joining us live this morning. Good morning, Liv. You are at that dig site. It's pretty cool, isn't it?
Yes, good morning. Right behind me here is where that digging is taking place. The paleontologists here were given 3 months to uncover as many fossils as they can before construction on that substation begins. Diana Call, the executive director of the Dinosaur Discovery Site just across the street over here in St. George, says they're making good progress, thanks in part to a partnership with the city.
So it's about 200 million years, similar to the site across the street. Mostly what we're finding are fish fossils.
There's not really other sites of this age with the kinds of
dinosaurs that we have in them anywhere else in North America.
This dig project is part of the city's broader efforts to plan for growth alongside preservation of our archaeological and cultural resources.
Responsible growth is really trying to maintain the services that we provide and the quality of life and keep that going even through the growth. And that could be quite a challenge.
The city selected this site after 2 years of study, saying it was the best location both functionally and financially, which will benefit residents of St. George.
We're fully run off of our ratepayers, so any extra costs gets translated over to the ratepayers. And so by being able to save money and plan ahead, we can keep rates reliable and low.
Knowing they'd be breaking ground anyway, the city turned the substation project into an opportunity.
I choose to look at it as we would have never uncovered these rocks if this area wasn't developed. It would have stayed under the ground.
The city has helped us a lot with finding contractors and getting us information, getting us the permits, like those kind of things that need to be in place. Like they've taken care of it for us.
A lot of development has taken place in the vicinity over the last 15 years, and I'm not sure that any other of the developers have given an opportunity like this to the discovery site to be able to find the fossils.
What we'd really love to find is a new dinosaur species. Well, that would be amazing. So something that we could name, something that could like talk about St. George in a very different way.
Now this parcel of land behind me, it belongs to the city and it's about 20 acres large. 0.7 acres are devoted to that substation project, and the rest of this land can still be surveyed for fossils. However, paleontologists tell me that the timeline and the budget are still tight, and they're asking the community for donations of time or money to complete their efforts. Live in St. George, Liv Kelleher, KUTV 2 News.
So people can just show up and say, okay, I'll go out with a little brush and try to look for fossils. Is that the plan?
There's a little bit of training that has to happen in order to do that, but yes, essentially, if you want to volunteer, you can.
Again.
Okay.
Do they feel 3 months is enough time to do so? That seems like a huge project.
Yeah.
It is. I mean, it's going to be tight, but they are working as fast as they can, and they hope to uncover as much as they can, but there is a lot here.
Okay, yeah, that's amazing. That's a gold mine of fossils.
You're right.
Yeah.
All right. Anywho, good stuff. Here is a link to that right there, and there is an article too. It might be just basically a transcript of this same thing. Yeah. This is a project we're really planning for, called said even $10 donations help buy buckets, shovels, everything we need. Yeah, there you go. And we've got a wish list link here in the chat that way. Maybe they got a lot of volunteering after that, says TMK. I hope so. I hope they get many more volunteers because they need it. Shoot. And it's nice to see some new items here on the wish list. Portable saw, some rock hammers, medical bandages here, these jewelry loops. Good, they upped the quantity. Need 10 has 2. Yeah, these we really needed the site because a lot of the fossils are very, very small. Being able to embiggen them, in our view, helps to identify them. Good stuff. Good stuff. Anyway, so if any of you would like to contribute, there's a way that you can make a real material difference through just a simple Amazon purchase. They go straight to the museum after this, and they get used on site like within a day of showing up. Oh yeah. Anyhow, good stuff. Lovely. That's, I think, enough of an update for today. I don't want to bother Andrew today because I know today's his day off. But we'll give him a call tomorrow for another update from the site. And, yeah. I'm excited. Things are going well there. And I think this community has played a part in that. Making donations, helping get the word out, sharing things on social media. Our very own Claire Burr has been editing some videos and then distributing them across the internet, and people have been watching those and then signing up to volunteer, which has been awesome. So anything that we can do to help this project out, it's been I feel really good about that. You know, we've been able to make a real difference there. I'm proud to have done so. Thank you, everybody, for your support in that. With that said, we have got some Marsh Madness to continue with today. Here is our official results as they stand currently. We've got 4 different dinosaurs to cover, 2 different matchups before the end of today's stream. So, let's jump right in, shall we? We're gonna have Apatosaurus versus Ceratosaurus, and Diplodocus versus Dryosaurus. I think first off, let's do Apatosaurus versus Ceratosaurus. We have a Ceratosaurus right here in the office right now. This is a 3D print. I actually sculpted this guy. This was a Halloween costume at one point. There we are. Here's my tip. If you want to get out of jury duty, dress as a dinosaur. Dress up like a dinosaur.
Oh my gosh, I love it. Wow.
Yeah. You'll get dismissed every time. And I think it's because lawyers, most of them have seen Jurassic Park, the movie, in law school. I assume this is what people do in law school. They watch movies all day. And they've seen what happens to the lawyer in that movie. They don't want that happening to them. So if you're dressed as a dinosaur, they'll just instinctively send you home. So there you go. It's a tip from old Danny for you. That's Ceratosaurus. Now, Ceratosaurus, where to begin? Years ago, I made like a little video thing on Ceratosaurus. Let me see if I can find that. Do I still have that? Let's search the desktop for Ceratosaurus. Ceratosaurus video. There we go. Where's the finished one, though? Let's see here. Ceratosaurus montage. That should be it. So here's a montage of Ceratosaurus clips from different films. Really popular dinosaur in film. This is one of the first big theropods to get named and described. you go. Ceratosaurus has got a lot of prominence in pop culture despite not being known from very many specimens. There's like a handful of good Ceratosaurus specimens, I think like 4 or 5, that have ever been found. It's not a very common dinosaur in the Morrison Formation. You can see a lovely mount of this at the Natural History Museum of Utah. In fact, I bet you we can find this here. Salt Lake. Here we go. Let's find our Ceratosaurus here.
I think it was named in like the 60s or 70s or something like that, Marshosaurus. But yeah.
Marshosaurus was named in 1976. Marshosaurus bisontesmus. It's named after the bicentennial. See? Every day, learning and growing.
Yeah.
And I gotta point out number 7, which is one of my favorite Ceratops.
Diplodocus, yeah.
Yeah.
I came here in, it must have been like 2015, I think autumn of 2015, to photograph that specimen for a friend of mine. He was thinking of including it in his doctoral thesis. But really cool. Diplodocus is really awesome. Yeah. Yeah. Yeah, thank you again so much. Really appreciate it. Yeah.
Yeah. Always good to talk to paleo people.
Thanks. Yeah, here, let's go back down to Barosaurus real quick. And we'll take a closer look at this adult Allosaurus. Marsh's. But it is a speculative thing. I mean, like,
if Minnie comes in, it's because she bullied me into letting her out of my room. Not my fault. Hello, Minnie Pie. How are you doing? Do you want to come say hi? Minnie Pie. Hey. Come up here. Oh, your pupils are really big. Are you still kind of loopy from the anesthesia? Oh, yeah. Can I pick you up? You want to try and jump up? Okay, you made it. Good for you, Minnie Pie. Well, how you doing? Things good? Yeah, Minnie will not be contained. No. Can she have some treats right now, Lordy? Is that okay? Is she good to eat? Minnie Pie, good to see you. Good to see. Oh, you fell over. You're still a little loopy. Still a little loopy. After your vet visit. Yeah. Here you go. Bring you soft ones. Oh, okay. Okay. Oh, don't fall off the desk, Minnie Pie. Hey, come here. Look at what we got for you. What magic is this? No, you're wrong. Stepping on my soundboard. You're stepping on my soundboard. Dude, no, Windows, I don't want to turn on toggle keys. Stop it. Goodness. You're a chaos machine, Minnie Pie. Don't fall off the desk. Don't do it. I know you're loopy from the anesthesia. I don't want you to fall off the desk again. Calm yourself. Hey, look. Shh. Calm down. Hey, look at what I got for you. Oh, gross. My eye. There we go. Okay, look. Hey. Okay, calm. Minnie Pie, you have to calm down. Yeah, look. You're not even eating it. You're just rubbing it on your face. Come here. Look. Oh, that smells vile. There we go. Look at that. Oh, yeah. There we go. Look at that. Yeah, good stuff. What do you think? We can see where you got shaved. You got a little shave spot there. You're a mess, Mini Pie. You're a mess. Look at you. Trying to bite the tube. This stuff smells awful. You like it? You're not a vegetarian, Mini Pie. Certainly not. Yeah. Look at all that. I'm gonna eat this whole thinking about it before a minute. There we go. There we go. It's so fun right now. Those dilated pupils. Oh. Oh, you want more? Okay. Don't bite me. Special treat coming back from the doctor. I know that must have been stressful. So I'm glad you get a special reward afterward. Okay, let's be methodical about this. We get every last little bit. Pulling it up for you. What's that? What do you see? Everywhere. There we go, and I think, oh, got a little bit left. Got a little bit left. That's it. That's it. All good. Look, there's some still on the desk. You can lick that up. Got it on your whiskers, got it on your forehead. All right, Mini Pie. All right, Mini Pie. That's it, Mini Pie. That's it. Oh, gross. You got it on my shorts, too. All over the place. Oh, don't fall off the desk. Oh, fall off. Oh, careful. Hey, don't drink my water either. Hey, stop it. Hey, I'm gonna pick you up and I'm gonna put you on the ground, okay? There you go. There you go. My goodness. I thought she was crazy when she's not partially anesthetized. Do you need help bringing her back? Yeah, she almost fell off the desk numerous times. If you want to pick her up real quick, I'll set this to the side. All right. Thanks, Lordy. All right. She's such a mess. She is. Yeah. Oh boy, go home, Mini Pie. You're in no condition to be on screen. But it is nice to know that she's okay. Absolutely, Rushman. Yeah. Anyway, Ceratosaurus. Here's me and Lordy here in 2021, I think.
Yeah. There's no one species of bird. All birds evolved from dinosaurs, and all birds...
Extinction.
Forward a little bit.
So we're gonna...
Hang on. This is messed up. We were at the wrong timestamp because Mini Pie was stepping on the keyboard. Here we go. Ceratosaurus.
That is...
Wait, is this Marshosaurus right here?
Yeah, Marshosaurus.
Yeah, this I always thought Marshosaurus was so much smaller than this. I can't remember if it's Marshosaurus or Stokesaurus. Stokesaurus is the small one, Danny.
Early Tyrannosaur relative? It's probably Stokesaurus.
It is.
But yeah, really cool. Marshosaurus, I think, was first discovered in the Cleveland Lloyd Quarry. I think that was like the first place that it was ever found. It might still be the only place it's ever been found.
I didn't know that. I thought.
But yeah.
That's so cool. I didn't know.
I think he was thinking of it.
We have to grab it. Where's our Ceratosaurus?
A lot of that is much here.
Then who's the next?
One in the front.
The one in the back.
The one I was going to ask you that was because this is Allosaurus, right? Another Allosaurus.
This is actually Marshosaurus.
No, Marshosaurus.
Yeah.
Which
named
is,
after
I guess, a megalosaur. Its skull looks very megalosaury.
Look at that. And then who's the one on the ground? Who's she?
Stegosaurus.
Yeah. Poor Stegosaurus.
R.I.P. that Stegosaurus.
Yeah.
Oh, and the plates.
And the plates. Yeah, the plates are not as visible from this angle.
First,
yeah. But yeah. I've long wondered, like, what is going on in the Morrison with all of these big theropod dinosaurs? You've got so many distinct kinds. You've got Allosaurus, you've got Ceratosaurus, you've got Torvosaurus, now we've got Marshosaurus. Is this niche differentiation? Are they all like doing a different job? Are they feeding on different prey? Are they living in slightly different habitats? Like, are some of them living on the floodplains? Some of them are up in the hills. Some of them are, in the forests. I don't know. Think about in modern day Africa. You've got a bunch of different big cat species. You've got leopards, you've got cheetahs, you've got lions. And they all kind of do something different, They've got a different lifestyle, they've got different habitats. I wonder if Morrison big theropods like that are kind of the same way. Allosaurus is by far the most common, not just at Cleveland Lloyd, but throughout the Morrison Formation. Ceratosaurus is a little more rare. Torvosaurus seems rarer still, and then Marshosaurus too. Yeah. I wonder if even these guys might be oversplit, though. Do we have enough material? Oh, yeah. I like how it's... Because all birds are theropods. I love those...
So this is one of my favorite dinosaur mounts in the world. It's really beautiful, this Ceratosaurus. Osteoderms, neural spines along the tops of the vertebrae there. That is so cool. These guys are often reconstructed with like little armor plates. Just little ones, like little pebbly ones. All over their backs. And they probably had that. A lot of ceratosaurs seem to have some kind of pebbly osteoderm type thing going on. Look at that. The Ceratosaurus is big, long teeth. Pretty big teeth compared to its skull size. So this is why I ended up doing the Halloween costume Ceratosaurus. Here, I can find that. Let's see. Instagram Paleontologizing. Help if I would spell that correctly, huh? There we go. There's my Ceratosaurus costume, I think from 2021. Come on. And it's not working. I don't know why. Weird. Anywho, that'll work for now. I did this because I wanted to come up with a dinosaur skeleton that would be instantly recognizable, but not as cliche as, say, Tyrannosaurus. So what's like a really distinctive dinosaur? You can tell what it is at a glance, and we've got decent skeleton material from it. I decided on Ceratosaurus. We just kept encountering Ceratosaurus again and again and again on that big road trip that summer. At the museum in Salt Lake, at the museum in Lehi, Utah, at various different museums. Dinosaur National Monument, too. Just again and again, Ceratosaurus. Yeah. Pretty neat. Ceratosaurus is an interesting dinosaur. And where is Ceratosaurus located on the taxonomic tree? Starman, great question. So if we pull up a phylogeny of theropods, first, just a simple dinosaur phylogeny. Dinosaurs start off right here. Ceratosaurus would be basically a branch coming off of theropods, but before you get to spinosaurs. So it's fairly basal. Here we go. This should give you a pretty good idea. So these are just theropod dinosaurs. This is just a theropod phylogeny here. So Ceratosaurus and the Ceratosaurids, they're pretty early branching. So they're more advanced than like your Coelophysoids and things like Dilophosaurus. But they're, yeah, before you get to the Abelisaurs, you've got Ceratosaurs there. Abelisaurs are actually a kind of Ceratosaurian. They survive until the end of the Cretaceous. But Ceratosaurus seem to go extinct at the end of the Jurassic. And, yeah, just before the Megalosaurs do. Megalosaurs should actually be a little bit further out in time, because they go extinct in, like, the Middle Cretaceous. The Spinosaurids are the last surviving Megalosauroids. Yeah. Yeah. Anywho. Good stuff. So what else can we say about Ceratosaurus? This is, like I mentioned earlier, one of the first of the big meat-eating dinosaurs that were described. When Othniel Charles Marsh published Ceratosaurus, pretty early on, I think. There were not a lot of big meat-eating dinosaurs that were known. And Ceratosaurus isn't even necessarily that big. It's definitely smaller than like the larger Allosaurus specimens that we have. Probably doing something slightly different in its ecosystem to avoid competition with Allosaurus. Yeah. Just really charismatic animal. I can show you another Ceratosaurus clip before we get into the original paper. Watch out, little Dryosaurus. We'll be talking about Dryosaurus in a little bit for our next matchup. Watch out, little Dryosaurus. And what will happen here? You'll have to watch When Dinosaurs Roamed America to find out. Link there. And Ceratosaurus did get a bit part in Jurassic Park 3. Here. There. So, oh, here, let me set up the clip. They're trying to find the satellite phone in order to be able to call for help to get off of the island. And the guy who was holding the satellite phone ended up getting eaten by a Spinosaurus. And so it's kind of a running joke throughout the film. Yeah. And there's a bunch of Spinosaur dung. Petrodactylus says, I need to change my ringtone to this sound. This is my ringtone on my phone. Has been for years and years. And there you go, Lordy, yeah. Ceratosaurus. He's like, nope. Anyway, yeah. Nowadays, Ceratosaurus is known for more specimens than just the original that Marsh published on. In 1884, pretty early on. Good stuff. There's that original illustration of Ceratosaurus. This was super influential at the time. And I happen to have this up in my office today. There it is right there. Yeah. I also have a 3D print of the holotype Ceratosaurus skull, but it's not painted yet. Or else I'd be showing that off. Here, it's over here. So busy, I haven't had time to finish this, but there's the holotype Ceratosaurus skull, 3D printed in black filament. But this gives you a sense for how big this animal is. This is not the largest Ceratosaurus specimen that's been yet found, but yeah, it's not huge, but it's not tiny either. One of these days, I'll get this finished so we can use it in our background. Ceratosaurus. And Frizzy Izzy, thank you for the follow. Welcome to Paleontology. So the original Ceratosaurus skeleton was found near Garden Park, north of Canyon City, Colorado. Good stuff. Here's how much they had of the original skeleton there. Decent amount, honestly. Not too shabby. Let's take a look at that original paper from O.C. Marsh in 1884. Here we go. Let's see. Marsh Ceratosaurus. I'm looking this up in my collection of dinosaur papers here. And I don't think that's the original one. This has got to be it right here. Yeah. Very nice. I think this is the original descriptive paper. Should be 1884, right? Yeah. So let's go ahead and read that, shall we? This was Ceratosaurus's Introduction to the World at Large, 1884. New Jurassic Dinosaurs. Oh wait, no, this is in... Hang on. No, this is not what I'm looking for. This is not the original scientific publication. This is in the journal Science. This is heralding this as an important find, but this is not the original publication. So let me find that. There we go. Good stuff. Here it is, right here. Principal Characters of American Jurassic Dinosaurs by Professor O.C. Marsh. Part 8, The Order Theropoda. The carnivorous Dinosauria form a well-marked order, which the writer has called Theropoda. Marsh actually coined the word theropod in his classification of this group. Although much has been written about these reptiles since Buckland described Megalosaurus in 1824, little has really been made out in regard to the structure of the skull, and many portions of the skeleton still remain to be determined. Of the carnivorous dinosaurs from the American Jurassic, there are 4 genera, which each represents apparently a distinct family. These genera are Allosaurus, Coelurus, Labrosaurus, and the new genus Ceratosaurus, here described. Labrosaurus no longer considered valid, probably just Allosaurus. The skull of Ceratosaurus nasicornis is very large in proportion to the rest of the skeleton. The posterior region is elevated and moderately expanded transversely. The facial portion is elongate and tapers gradually to the muzzle. Seen from above, the skull resembles in general outline that of a crocodile. The nasal openings are separate and lateral, and here are placed near the end of the snout as shown in plate B. Kind of goes into more detail about this. Hopefully we've got some figures here. But this was the original publication introducing Ceratosaurus to the world, 1884. There we go. And in fact, I think it was in March of 1884. Yeah, skull of Ceratosaurus nasicornis, Marsh, 1/6 natural size. There you go. Yeah, Marsh publication longer than a page. There you go, Charlie's Dragon. Yeah. He had a lot to talk about here. Date here. When was this first published? January to June 1884. Okay. And there you go. Ceratosaurus. One of everybody's favorite dinosaurs, whether they like to admit it or not. Very cool critter. Very charismatic. And something of a celebrity, Ceratosaurus, especially early on in dinosaur cinema. So there you go. Ceratosaurus. Next, the challenger. Take a look here. Our challenger is Apatosaurus. Ceratosaurus is seated number 5 here. Apatosaurus, number 12. Interesting, and that Apatosaurus may or may not be the same animal as Brontosaurus. Depends on whom you ask. But, here we go. Apatosaurus is one of your classic dinosaurs. And we have another clip from When Dinosaurs Roamed America to help introduce it here.
Repredator.
There's Jim Kirkland there again. Here we go. Apatosaurus. I'm gonna get a snack here real quick. I'm getting really hungry. I don't relate. There we go. Apatosaurus, you get the idea. Next dude says, I always wonder how far you can feel the tremors from them walking. I do actually doubt you'd be able to feel them much at all. Given that animals like this, they've got big fleshy pads on the ends of their limbs. You know, they wouldn't have been stomping around trying to make the earth shake. You know, in the same way that, like, an elephant could sneak up on you, as long as it doesn't breathe too heavily. These guys probably could, too. Elephants can walk surprisingly quietly. It's not like they shake the ground unless they're really running or trying to shake the ground. That'd be a very inefficient way of moving, you know? So I suspect these guys would have been the same way. Probably pretty soft padded steps. Anywho. Oh, and Charlie's Dragon, yeah. They do look similar to the Walking with Dinosaurs. Diplodocus. There's the Apatosaurus here. And yeah, from the front, they do look a lot like the Diplodocus. But these guys are far more bulky. Apatosaurus and Diplodocus are both Diplodocids, as you know, Charlie's Dragon. But, Apatosaurus is far more robust. Very big, bulky skeleton. Look at how thick that neck is. It's a chunky guy. So here we've got from left to right, in reading order, in English at least. Brachiosaurus, Apatosaurus, Diplodocus. Diplodocus is far more slender than Apatosaurus is. Apatosaurus is really big and bulky. And those big neck vertebrae right there, really stocky. They almost do make the neck look a little bit shorter, but it's not a short neck. That neck would have been like almost rectangular in cross-section like this. So, really a bulky animal. Apatosaurus. It's, oh, I love this depiction right here. That's so nice. I wish I could get one of these, you know? But I don't think they're available anymore, and when they were pricey. $359. But just lovely. This is like one of the best depictions I've ever seen of Apatosaurus. Just lovely, you know? Yeah. And Madam 33 says, do they know for sure Apatosaurus would have had those spikes on its back and neck? We don't know. I think we're pretty darn certain that Diplodocus had those. Apatosaurus is a close relative, but we don't know if it had those same kind of iguana-like spines on its neck. You kind of see a suggestion of that here. It's subtle along the tail there, right here. They're kind of truncated. But yeah, we don't know whether they had that or not. And there's another really lovely Apatosaurus illustration I need to find. With Apatosaurus just grazing in this almost a boggy fern fen. Like Ethan's song. If you were here for that during the cold open today. I don't know if I'm going to be able to find that. It was such a cool illustration. Like really atmospheric. It's not on here. Darn. What I'm going to do is just search for Apatosaurus. And I know there was a lot of blue in the illustration. And so... yeah, let's search for teal. See if it shows up anywhere. Not seeing it so far. It was so good. It's a shame I can't find it right now. I would love this illustration. They didn't call it Brontosaurus, did they? Chance they did. That's okay. So, how did this happen with Apatosaurus and Brontosaurus? Where did all that confusion start in the first place? Yeah. And Summer wants to know, what dinosaurs did it coexist with other than Allosaurus? All of the dinosaurs from the Morrison Formation, more or less. So, at the end of the Jurassic here in North America, you've got these sauropods like Apatosaurus here in the green. Diplodocus, or maybe Barosaurus, up there. Camptosaurus, Allosaurus, Stegosaurus, Torvosaurus, Dryosaurus. All of the dinosaurs on the left side of our bracket all lived at the same time in the same place. Stegosaurus, Nanosaurus, Diplodocus, Dryosaurus, Allosaurus, Camptosaurus, Apatosaurus, Ceratosaurus. All of them. Also Barosaurus over here, who's been eliminated, unfortunately, for Barosaurus. And a number of others, too. lots of dinosaurs in the Morrison Formation. Various sauropods, theropods, ornithopods. Yeah. Different dinosaurs from the Morrison. Here's Camptosaurus and Allosaurus here. Actually, I like those illustrations. Those are nice. Yeah. There you go. Good stuff. Good stuff. Yeah. But yeah, what's the difference with Apatosaurus and Brontosaurus? Let's take a look.
Jim is the latest in a long line of dinosaur hunters who have scoured these hills. The heyday for dinosaur hunting was 100 years ago.
Well, kind of. It's also today. It is the golden age of dinosaur paleontology nowadays, but those halcyon days of walking over hither and yon and just finding dinosaurs all over the place before everything got all fenced in. That was this time during the Bone Wars.
Expeditions headed west, financed by the great museums of the East.
Like Othniel Charles Marsh funded these.
In just 20 years, 100 dinosaurs were found.
Watercolors by Arthur Lakes there.
Competition for these bones was fierce, and inevitably, mistakes occurred.
Oh, yeah.
One of the greatest collectors was Othniel Marsh, head of the Peabody Museum at Yale.
Namesake of Marsh Madness.
In 1879, one of his expeditions uncovered the bones of the very first brontosaur. It was a remarkable specimen. All it lacked was a head. That did not deter Marsh. He stuck on one he'd found 400 miles away. And that's the way all brontosaurs have appeared until now. Marsh had guessed, but he guessed wrong. So at museums like the Field Museum in Chicago, a series of face-saving operations are underway.
Face-saving, get it?
The changes are necessary because these long-necked dinosaurs come in two quite different kinds. And while Brontosaur's body belongs to one group, its head belongs to the other. The controversy about how Brontosaurs should look isn't new. It started in the 1920s, when this quite different head was found.
Yep.
The Carnegie Museum in Pittsburgh sent out collectors to search for new dinosaurs. One of these expeditions found a brontosaur, and this time it had a head. The discovery delighted the expedition leader, Walter Holland, in the dark suit here. But an argument broke out when Henry Osborne, the acknowledged expert on brontosaurs, told him the new head was wrong and should not be used.
Huh.
Holland wasn't convinced. When he mounted the brontosaur in his museum, he left it without any head at all.
Which is kind of nuts. Like, this is a bold choice. Holland is like, we don't know what the head looks like. Let's just mount it headless. Think of the number of questions that museum staff must have gotten from visitors at the time. Like, this is a real choice he was making there.
After he retired, an old-style head was slipped quietly into place. Yet Holland was right after all, and Marsh's heads are beginning to disappear.
Yep.
Just 100 years after they were first discovered, brontosaurs are finally assuming their proper appearance. And if they seem to appreciate the joke, it's doubtful if their discoverer, Othniel Marsh, would have been quite so amused.
Yeah, anyway, the finding the wrong head is not what led to the name Brontosaurus. It's more like Marsh was just naming sauropods left and right, and he found an Apatosaurus, named it Apatosaurus. He found something that looked extremely similar and named it Brontosaurus. I think it was like Elmer Riggs back in around 1910 or so realized that these are probably the same animal. And so he quietly, started saying, well, these are the same creature. since Apatosaurus was named before Brontosaurus, if they're the same animal, use the name that was published first. So, Apatosaurus. And so for a long time, this is what you would see, you know. It's not Brontosaurus. Brontosaurus is not really a valid name. It's Apatosaurus instead. Even though the name Brontosaurus was really beloved by the public, it's a great name. It's like objectively a better name than Apatosaurus. Apatosaurus, phonetically, it doesn't sound as cool. The name means deceptive lizard. What? How is that relevant? Brontosaurus. Such a good name. It means thunder lizard. And it's got a real euphonious quality to it, you know? Brontosaurus. Just wonderful. But unfortunately, if both of those names apply to the same animal, according to the rules, Apatosaurus is what we have to keep because that was published first. There was a paper published in 2015. Yeah. Welcome back, Brontosaurus, and other thoughts on Shop et al. 2015. You can read more about that here. But Emmanuel Shop and co-authors did like a big review of sauropods. And they said, well, those specimens, the original Apatosaurus specimen and the original Brontosaurus specimen, they're saying these look different enough that we could justify calling them different things. And so they wanted to bring the name Brontosaurus back. This has seen a mixed response from different sauropod workers. There's the Sauropod Vertebra Picture of the Week blog about this from 2015. But here we go. Extensive 2015 paper found Brontosaurus to be a valid name. However, the status of Brontosaurus is still uncertain, with some paleontologists still considering it a synonym of Apatosaurus. Just by default, this is what I do nowadays. I don't work on sauropods, so I don't have a really strong opinion about this, but when it comes right down to it, I think that individual variation and stratigraphic variation and ontogenetic variation are probably underappreciated in sauropods. I don't necessarily think that every single sauropod specimen in the Morrison Formation is from a different species or a different genus. So I say Apatosaurus instead of Brontosaurus. Maybe that'll change in the future. But, yeah. Anyhow. And Petrodactylus says, I'm actually so happy this is being brought up. I've always been a little confused on what was the current standing of for Brontosaurus because of that article. Yeah, it's complicated. Like many things in science, we're working at the very frontiers of human knowledge. We don't have a tremendous amount of information. And so there's controversy about that still. Does that make sense? Yeah. Anyhow, Apatosaurus. Just lovely animal. Kind of one of your quintessential Jurassic sauropods. When you're thinking about the Morrison Formation, Apatosaurus is one of those dinosaurs that should really be at the kind of at the forefront of your thoughts there. Such a cool animal. Here's sauropod researcher Matt Wadle years ago. I guess he got a model of this. He's pretty happy about it. Anywho, Apatosaurus. Let's look at the original descriptive paper wherein Marsh describes Apatosaurus for the first time. It would have been 1877, perhaps? Yeah, there we go. So here we have the original descriptive paper from 1877 by Othniel Charles Marsh, introducing Apatosaurus to the world. Notice of new dinosaurian reptiles from the Jurassic Formation by Professor O.C. Marsh. Yeah. And we'll skip to Apatosaurus. Apatosaurus ajax. New genus, new species. Another gigantic dinosaur, allied to the above, then of scarcely less interest, is represented in the Yale Museum by a nearly complete skeleton and excellent preservation. It is from the Jurassic beds of the eastern foothills of the Rocky Mountains, but from a somewhat lower horizon than the type of Atlantosaurus. The cervical vertebrae are strongly epistocylous and are rendered comparatively light by their large pneumatic cavities in the center. The anterior dorsals have similar characters. So here he is, he's talking about the anatomy of the vertebrae. The animal must have been between 50 and 60 feet in length and more than 30 feet in height when erect. So that's Apatosaurus ajax. And then he also describes Apatosaurus grandis in the same paper. Another huge dinosaur, apparently of the same genus but of smaller size, is represented by the Yale Museum by the more important parts of the skeleton and remarkable preservation. In this specimen, the cervical vertebrae have the walls of the centra very thin. The caudals are preserved and elongated and slender, indicating a long tail. The femur is comparatively short and without a third trochanter. The greater trochanter is much lower than the head of the femur and continuous with it. Anywho, really short paper introducing these dinosaurs to the world, but this is what Marsh did back in the day. Short, quick, simple papers meant to scoop his rival Cope and get his dinosaurs out before Cope could. Dinosaurs and other critters as well. Any kind of new fossil organism that they were publishing. So there you go. Apatosaurus's first introduction to the world. Later on, Marsh would publish on Apatosaurus some more with illustrations and stuff, but that was it. The very first time that Apatosaurus was ever published on. So with that, we've looked at Ceratosaurus, we've looked at Apatosaurus, we've looked at pop culture depictions of them, we've looked at the original descriptive publications. We talked about their significance both a little bit, answered some questions, and now let's have a matchup of these two different dinosaurs. Find a good illustration of both of these here. Ceratosaurus. There we are. That's not too shabby. I like that one. And now all right, let's begin our poll. You, chat, get to decide who moves on to the next round. Ceratosaurus versus Apatosaurus. Apatosaurus or Ceratosaurus. Let's do a 3-minute tournament right here. When we're thinking about which dinosaur you want to vote for, you can think about this in terms of which dinosaur is your favorite, which one do you think looks cooler, which one would win in a fight, which one would make a better pet, whatever. Pick based on your own criteria, but understand that you're picking which dinosaur is going to move on to the next round. So which of these two dinosaurs would you like to hear more about? Which one would you like to see expounded upon further? Expanded upon further, I should say. Vote based on that criteria, first and foremost. And with that, we'll begin our poll.
Hold on to your butts.
Start. results. Right there. And then pull up our 2 dinosaurs here. Apatosaurus and Ceratosaurus. So far, Apatosaurus is beating Ceratosaurus 13-9. I find that surprising. Normally, the theropods just run away with these. It looks like Apatosaurus might be delivering us an upset here. We shall see. Although here comes Ceratosaurus, garnering a few more votes. It's almost neck and neck right now. And it is tied, 14-14. This could be a close one, folks, as we approach the halfway mark. Holy cow, and it is still 14-14. It is tied right now. And if it was neck and neck, Apata would really win with the neck he's got. There you go, Clockwork Griffin, yeah. We are at the halfway mark, and Ceratosaurus is pulled into the lead. 16-14 now. 17-16. Apatosaurus is catching back up. Now it's 19-16. With less than half the time left, it looks like Ceratosaurus might pull this off. Let's see. Spiky Theropod, let's go, says Casey Snowart. It is fun to draw. Well, Apatosaurus is fun to draw too. These are both worthy competitors, both very charismatic dinosaurs. Ceratosaurus pulling ahead 21-18. It seems there are very few undecided voters still left in the chat. We'll see. Apatosaurus could still win this. 19-21 now. Ceratosaurus still in the lead. Oh, Apatosaurus there, 20-22. Ceratosaurus still leading by 2 votes. Nope, make that 1 vote now. This is a dead heat. It's anybody's game. Let's see. This one is exciting, Lenina. Final 10 seconds here. Ceratosaurus leading by 2. Nope, leading by just 1 now. It is so close. And there we go. It's a tie. It's a tie, folks. Holy cow. We have never had this before. Holy moly. It's a tie. 23-23. Do we have a plan for this? We'll have to do a rematch at the end of the stream. We're gonna move on to our next game. Our next matchup between Diplodocus and Dryosaurus. And then right after that, we'll do Apatosaurus versus Ceratosaurus again. My goodness. That is wild. Yeah. And Petrodactylus says I would have voted Ceratosaurus. Shoot. It's tied there. Petrodactylus. It is tied. Apatosaurus and Ceratosaurus. We're gonna have a rematch. Yeah. Well, some of this is all about the voter turnout, you know? You would have been the tiebreaker? Yeah, Petrodactylus. Shoot. Well, keep watching, because we will return to this. We will return to this. But for right now, we've got 2 other dinosaurs to look at. Diplodocus and Dryosaurus. Here, when we first started Marsh Madness, I kind of jokingly said, And my money's on Dryosaurus to win the whole thing. Here we go. I said my money's on Dryosaurus. Here's my bracket that I filled out at the beginning of the Marsh Madness season. With Dryosaurus winning in the end, we'll see if that happens. Dryosaurus is going to have to beat Diplodocus here in order for that to play out in the way that I had predicted. Let's start off with Diplodocus here. Diplodocus is one of the better-known dinosaurs to the general public, especially if you're from Europe, particularly the UK. Kind of funny that a dinosaur from Wyoming is possibly the most famous dinosaur in the UK, apart from maybe Tyrannosaurus. But yeah, Diplodocus. Diplodocus was originally discovered by crews hired by Othniel Charles Marsh, hence it being part of Marsh Madness. Diplodocus is a very close relative of Apatosaurus, we were talking about just a few moments ago. But Diplodocus is far more slender than Apatosaurus is. If Apatosaurus is a big old chonker, Diplodocus is much more lithe, much more skinny. You can think of it as being less of a bruiser, a little bit more kind of graceful. There's multiple species that we now have of Diplodocus. And, yeah, they are pretty cool. And yeah, I guess in the grand scheme of things, Diplodocus isn't super closely related to Apatosaurus. We've got two subfamilies within Diplodocidae, which is named after Diplodocus. We've got Apatosaurinae, they tend to be a bit chunkier, and Diplodocinae, they tend to be more skinny, more lithe. Diplodocus, how to introduce this animal in video. Here we go. Walking with Dinosaurs had some lovely depictions of Diplodocus. Here we go. This'll work. Just lovely. Look at that. Yeah. Time of the Titans. Yeah. Good stuff. Here, take a look at this.
So now, after 150 million years, we've got a pretty good idea of what Dippy looked like.
But how did she behave?
And this is wrong. Those hands are wrong. There should be only the claw and the thumb should be visible. The rest of these are like, there's no unguals there, as far as I know. This is one of your most beloved dinosaurs, especially in Europe.
Well, animals her size and weight must have moved in a rather ponderous way. And in any case, since she was a vegetarian, as we know from her teeth, she had no need to be speedy to get her food.
This is in the Natural History Museum in London.
But it's the tiny bones in Dippy's inner ear that can give us a clue as to what she sounded like. These little bones are basically the same shape as that of the dinosaur's closest relatives, birds. The range of sounds a bird hears is related to its size. A small bird makes and hears high-pitched sounds, whereas large birds communicate with low-pitched sounds.
Generally speaking, yeah.
So huge Dippy, with her inner ear bones shaped like those of a bird, could probably hear very low-pitched frequencies of sound. And she could probably make them, too.
And I'm going to try and go now, yeah. I'm trying to go to the NHM.
We know that elephants today can communicate using infrasound, sound with frequencies so low they're below human hearing. And those sounds travel through the ground, sometimes for many miles, and are detected by elephants through their large, flat, sensitive feet.
Dippy, too, had large, flat feet. So maybe the giant dinosaurs communicated with one another in much the same way, as well as by bellowing. Her long tail would have helped to balance her long, heavy neck. But why was her neck so long? The most likely explanation seems to be that it helped her to reach leaves in all sorts of difficult places.
Leaves, or maybe
But in
fern
order
fronds,
to reach the
horsetails.
highest, most succulent leaves in the forest, it seems likely that Dippy would have reared up on her hind legs. Come on, Dippy.
May or may not have been a typical behavior. We're not really sure. Denver Fowler's got some opinions about this. We were talking about it. Lovely. Yeah, good stuff. Here's a link to that video right here from Nature on PBS. So yeah, Diplodocus. This is a dinosaur that many of you in the chat are almost certainly pretty familiar with. I've got a big plastic Diplodocus right here, which I am very excited about. Yeah. When I got that, I was like, yes. Oh, man. Yeah. What to know about Diplodocus? Unlike Apatosaurus, it's very slender. Probably about 2/3 the weight, maybe even half the weight of an equivalent length Apatosaurus. It's an animal that's far less bulky. We're not really sure why that is. Like, why are these animals different from one another? What does it say about their lifestyles? But yeah. And I'm looking for clips from Prehistoric Kingdom, and I don't see it. Do they not have Diplodocus? They might not. Anyhow, yeah. Good stuff. Diplodocus. And next up, the challenger to Diplodocus. Truly, the king of the dinosaurs. The pinnacle of dinosaur evolution actually came early on. No later than the end of the Jurassic. Let me show it to you. Not Stegosaurus, but Dryosaurus. Look at it. Look at Dryosaurus. Snake Sock says that's John Goodman. No, that's Stegosaurus. And this is Dryosaurus here. Oh. And yeah, Claire, that is Camarasaurus in the background. Uh-oh. What's that? They're about to go against Diplodocus in our matchup. That's Dryosaurus from when dinosaurs roamed America. For a time when I was a kid, this is my very favorite dinosaur, probably because of when dinosaurs roamed America. I was really connected with this little dinosaur. I joke about Dryosaurus being truly the king of dinosaurs because it's one of those dinosaurs that's frequently overlooked. It's a small beaky plant eater. It's not particularly large or charismatic or fearsome. Doesn't have a lot of bells and whistles. It's, you know, it's just Dryosaurus. They may or may not have had kind of a feathery covering like this. They do get, you know, they're not tiny dinosaurs. Full-grown ones get fairly large, about the size of a small horse, maybe. They're an early iguanodontian dinosaur. So they're one of these dinosaurs that actually chewed their food a little bit. Like we were talking about iguanodontians earlier. They're, I joke that they're nobody's favorite dinosaur, but they should be everyone's favorite dinosaur. Just kind of underappreciated. Dryosaurus. Think of them kind of like, Jurassic deer. Or antelope or something like that. Maybe occupy a similar kind of niche. They feel kind of similar. Their primary defense would have been running, presumably. They would have had pretty keen senses, trying to avoid things like Ceratosaurus and Allosaurus, Torvosaurus and them. They're, you know, not the flashiest player around. They're, you know, kind of a lunch pail dinosaur. Come in, they do their ecological job day in and day out, and they survive. And they may have actually survived the end of Jurassic extinction event in North America. And, oh, we've got them in Prehistoric Kingdom. Very nice. I didn't know that.
A Dryosaurus.
Yeah.
Elegant, don't you? A Dryosaurus. Quite elegant, don't you think? They're especially cute as babies when they have big eyes and stubby noses, just like a puppy. They originally inhabited forested areas of the late Jurassic, with their name literally translating to tree lizard.
Yep.
I wonder
or
if they
lizard.
bark.
Nice. Dryosaurus. One of the only dinosaur video games I ever had as a kid was a Jurassic Park builder game. Called Jurassic Park Operation Genesis. And Dryosaurus was in that. There we go. Yeah. There were, I don't know how many different dinosaur taxa you could have in your park in that game. Big ones, small ones, different dinosaurs from the Jurassic Park films, and other ones not from the films, like Dryosaurus. And they were all They were all ranked based on like a star system. So there were your big charismatic 5-star dinosaurs, things like Tyrannosaurus and Spinosaurus. And then 4 and 3 and 2-star dinosaurs. The only 1-star dinosaur in the whole game was Dryosaurus. Yeah. The disrespect, says Salamander. I know, right? I like Dryosaurus. There's a special place in my heart for what we call, well, basal iguanodontians or even speedos, small-bodied early diverging ornithischians. These small, beaky, two-legged, running, plant-eating dinosaurs. They don't get nearly enough respect, in my opinion. Yeah, Dryosaurus. What we're going to do is look at the original descriptive paper for Diplodocus, and then Dryosaurus, and then we'll have our matchup here between these two dinosaurs. So let's pull up Diplodocus here. I think this is probably... yeah. Was it 1884 Diplodocus was first named? Let's see. By Marsh, 1878. Okay. Marsh, 1878. Gotta search for. Here we go. Odd. That's not the one we're looking for. That's not it either. Allosaurus, Allosaurus, Morosaurus, Atlantosaurus. Odd. Let's try and find it here. 1878. There's a chance that I'm just missing it on my hard drive here. This has got to be it here. Well, this is the same one I was looking at. Where's Diplodocus? There it is. All right, excellent. So, for Diplodocus, there we go. Let's look at its original introduction to the world here. Principal characters of American Jurassic Dinosaurs, Professor O.C. Marsh, Part 1 with 7 plates. On the flanks of the Rocky Mountains, a narrow belt of strata can be traced for several hundred miles, marked always by the bones of gigantic dinosaurs. Its presence above the characteristic Triassic red beds, and immediately below the hard sandstone of the Dakota Group. Hayden, Cope, and others have regarded this horizon as Cretaceous, but the abundant vertebrate remains now known from it prove its Jurassic age beyond a reasonable doubt. The writer examined a typical outcrop of this series on the western slope of the mountains in Wyoming, 1868, and determined it to be Jurassic, and he has recently named this series of the Atlantosaurus beds for the most striking vertebrates they contain. So let's jump down to his description of Apatosaurus here, or Diplodocus, excuse me. Diplodocus longus, new genus, new species. This genus includes some dinosaurs of very large size and are herbivorous in habit, and may be distinguished from the genera already known by the caudal vertebrae, which are elongated, deeply excavated below, and have double chevrons, with both anterior and posterior rami. To the last character, this generic name refers. Diplodocus means double beam. For those anterior and posterior rami of the caudal chevrons. Tibia also is very characteristic bone, as it is deeply grooved above to receive the fibula. Feet in this genus are very similar to those of Morosaurus, shown in plate 7. Anyway, good stuff. The original description of Diplodocus. And we have here illustrated. There we go, figure 3. Chevrons of Diplodocus right there. These are bones that hang down from the underside of the tail. So there you go. Apatosaurus. Or excuse me, Diplodocus. Gah! Diplodocus. Screaming for too long time. There's that animal's very first introduction. And now we move on to Dryosaurus before we hold our vote. 1894 is when Marsh named this critter. You find that here in my folder. 1894. Dryosaurus. And here we are. Introducing Dryosaurus to the world, 1894. The typical ornithopoda of the American Jurassic by O.C. Marsh. The herbivorous dinosaurs, now known from the Jurassic deposits of this country, consist mainly of the gigantic sauropoda and the huge stegosauria, both quadrupedal forms. A third group is the bipedal ornithopoda, which contains the genus Camptosaurus as well as various smaller and more bird-like types. The first two groups have been investigated by the writer and the main results published in this journal. The third group also received considerable attention during the above investigation, but a recent study both of the type specimens and additional material have revealed new points of interest, and some of these are given to the present article. Dryosaurus, new genus. Another genus of Jurassic dinosaurs, allied to Camptosaurus, but differing from it in many important respects, is Dryosaurus, the one here established. The type was described by the writer in 1878 under the name Laosaurus, and a tooth, the pelvis, and a hind leg were also figured. Additional material since received shows that this genus is quite distinct from Laosaurus, to which it was first referred, and is intermediate between Camptosaurus and that genus, as it is shown in the summary of characters from these genera given later in the present article. The only species of Dryosaurus at present known is the first type described, and in future this may be called Dryosaurus altus. Several specimens of the dinosaur are preserved in the Yale Museum, and they show it to have been in life about 12 feet long, one of the more slender and graceful members of the group. The known remains are all from the Atlantosaurus beds of Colorado and Wyoming. There you go. Dryosaurus, the first time that name was ever published in the scientific literature was in 1894 by O.C. Marsh. So there you go. Diplodocus versus Dryosaurus. With that, we can begin our matchup here and see which of these dinosaurs will be advancing to the next round. There we go. Let's do Diplodocus versus Dryosaurus here, and then after that we'll have our tiebreaker round between Ceratosaurus and Apatosaurus. Let's pull up a few good illustrations of each of these dinosaurs. One of each, rather. For Dryosaurus, it's not a bad one. It's pretty good too. Prehistoric Kingdom's got a good depiction. There we go. Yeah, we'll go with that for Dryosaurus. And, Diplodocus. There's an excellent depiction of that critter right there. So, let's begin our matchup here. New poll. Diplodocus versus Dryosaurus. Would you like Dryosaurus to advance to the next round? Or Diplodocus? Again, pick these dinosaurs based on whatever criterion you choose. Whatever you'd like. Which one's cuter? Which one's meaner? Which one's bigger? Which one's smaller? Which one will win in a fight? Which one do you have a personal connection to? Which one is known for better fossil material? Whatever. But choose with the understanding that your vote will contribute to determining who moves on to the next round, who shows up later, who gets talked about more. Which of these dinosaurs will be going home today, and which one will be continuing? With that said, let's start the poll. 3 minutes, starting now. Diplodocus and Dryosaurus here. So far, Diplodocus is in the lead, 15 votes to Dryosaurus's 10. But Dryosaurus could still come back. 14 to 16 now. Dryosaurus is catching up to Diplodocus. There we go. I did not expect it to be this close, to be honest. I thought Diplodocus would be walking away with this match. And they are currently tied 16 to 16 right now. This would be a real upset if Dryosaurus ends up beating Diplodocus. Diplodocus, one of the most beloved dinosaurs in the world, well known to the general public. And Dryosaurus has pulled ahead. Oh, now it's back to being tied 17 to 17. Diplodocus has pulled ahead with 18, now 19 to 17. We've got about half of our time left. And it could still go either way here. What do you bet this would be a second tie, says Nell? Oh, I hope not. I want this to be decisive. Because we got to do another rematch between Apatosaurus and Ceratosaurus after this. Diplodocus still holding on to that lead, 19 to 17 here. Petrodactylus says, I went with Diplodocus only because it's my dad's favorite dinosaur. Otherwise, they're tied for me. There's a lot to talk about with Diplodocus. I could also talk about Dryosaurus in the future. Again, my money was on Dryosaurus to win the whole thing, but it looks like Dryosaurus might be going home today. Although it's 18 to 19 now. Dryosaurus just behind by 1. And now they're tied. Holy cow. Don't let this be another tie. Oh, Diplodocus now in the lead with 20 to Dryosaurus's 19. And they're tied again with about 15 seconds left. Oh no. Dryosaurus is pulled ahead by 1 point. Could it be? Are we gonna have a Dryosaurus victory here? Oh, 21 to 21, they're tied again. Final seconds. It's a tie. Holy cow. How did we get another tie? Second tie of the night. This has never happened before. Wow. They are both really good dinosaurs. All 4 of these dinosaurs have been really good. You know, what we're going to have to do is, well, shoot, let's go back to our... Well, you know what? Maybe what we're going to do... Maybe we put all 4 of them together. And our final 2, the 2 that score the most points, are the ones that move on to the next round. 4-way vote? Let's do that. Let's do that. All right. Tiebreaker round. So, in alphabetical order, Apatosaurus, Ceratosaurus, Diplodocus, and Dryosaurus. We've got 3 minutes to make this happen. Let's do it.
Hold on to your butts.
Start the poll. View results. There we go. Apatosaurus coming out to the lead at first, swiftly overtaken by Diplodocus. Ceratosaurus, Dryosaurus still with no votes here. My goodness. We have Apatosaurus. We have Ceratosaurus. We have Dryosaurus. And we have Diplodocus. Who is going to be advancing to the next round? Who's going to be going home? Let's see here. Ceratosaurus currently in the lead. Apatosaurus and Diplodocus tied for second. Dryosaurus is fourth. Every vote here counts, everybody. It is still very close. Dryosaurus now leading over Diplodocus, tied with Apatosaurus. Diplodocus catching up again. Ceratosaurus pulling into a comfortable lead. 11 points to everybody else's 7 at this point. Apatosaurus advancing slightly. And 3-way tie for second, because of course. We'll see. Interesting that Apatosaurus is beating Diplodocus. Oh, I spoke too soon. They're both tied at 8 right now. Dryosaurus still in fourth. Looks like Dryosaurus might be going home. Oh, now we've got 3 dinosaurs tied for second. Oh boy. Ceratosaurus just got another vote. And we are running out of time here. There we go, like 1/4 of our time left. We've got 3 dinosaurs tied for second place. Ceratosaurus looks like it's gonna win this one. Yeah, my goodness. A few seconds left here. Apatosaurus just got another vote. Has pulled ahead. Diplodocus is now tied with Apatosaurus. And Dryosaurus now tied again. Don't tell me. Don't tell me. And with that... Holy cow. That was a real nail-biter there. At the very last moment, Dryosaurus squeaks ahead by the very margin of its predentary. Scooting in there. There we go. Holy cow. How was that for a matchup? Sauropods lost big today. They really did, Clockwork Griffin. I might take that. And put it in the Blue Sky post. My goodness. Here, let's open up the old Photoshop and let's do our updated bracket for today. Your bracket is partially salvaged. Mine too, Scorch Hellfire. Dryosaurus could still win the whole thing. Okay. Here is our bracket. Let's see. We can take that and we can... let's get rid of that. All right.
You need to take some of your own advice.
The Raven.
Aren't you the man who told me to live every week like it's Shark Week?
Aww.
And that nothing's impossible except for dinosaurs?
Oh.
Don't give up on life, sir.
Wow. The Raven, thank you for the 27 months of support. And yes, indeed.
That belongs in a museum.
Yeah. Thank you for your ongoing support. That means a lot to me. Appreciate you, the Raven. Here. Let's go ahead and... Here, what I'm going to do is I'm going to combine some of these. Merge shapes. There we go. So who gets eliminated today? Where is that? Alright, do I have to rasterize the shapes? Is that what's going on? I don't know what's going on with this. Rasterize layer. Okay, that's what it was. See that option earlier. Alright, Diplodocus is going home. Right there. Eliminated. Oops. Along with Apatosaurus right there. Goodbye, Apatosaurus. Oops. Sorry. Wrong scene. Yeah. Eliminated. What do we say to those?
Denied.
Yeah. I'm sorry. Apatosaurus and Diplodocus. It's, big losses for sauropods today. Let's grab that winner one right there. We're going to put that on our Dryosaurus. And our Ceratosaurus. Why is that not working? So Ceratosaurus will be moving on to the next round, as will Dryosaurus there. There we go. Excellent. Holy cow, and we're getting closer to a final champion here. Let's go ahead and circle our winners. Or circle the matches from today. There we go. We're not going to have scores for those just because it was a four-way matchup. But I'm glad that one dinosaur from each of those different matches did win. There we go. Let's go ahead and save that there. Save as PNG. April 2nd. Results. Beautiful. Final results here. Let's go ahead and upload our image. That's going to be Marsh Madness April 2nd results. Let's see. And 2 Marsh Madness matchups today. Our Morrison sauropods lost big. With Dryosaurus defeating Diplodocus. Right here, let's do with Ceratosaurus beating Apatosaurus and Dryosaurus defeating Diplodocus. In a major upset. Is it a major upset? Yeah. Yeah, next week we'll have Stegosaurus versus Dryosaurus and Allosaurus versus Ceratosaurus. Vote at twitch.tv/Paleontologizing. There we go. Excellent. Oh, and let's do alt text here. Current Marsh Madness results with Ceratosaurus and Dryosaurus victorious today. There we go. Save.
George from NY gifted a tier 1.
Hold on to your butt.
Post. Thank you, George from New York. I really appreciate that gift sub there. Thank you. There we go. Here is a link to that post if you'd like to share it. Has anybody got this bracket so far? Our current winners, moving on to the next round, are Stegosaurus, Dryosaurus, Allosaurus, Ceratosaurus, Torosaurus, Nodosaurus, and Triceratops. Has anybody got that bracket there? All but one. I had Torosaurus losing, says Lenina, which I thought it was going to lose there too. But it ended up beating Barosaurus. Go figure. Yeah. How closely does this match up with my bracket? It'd probably be quicker if I just clicked on the Marsh Madness post. There we go. I guess somebody else is posting Marsh Madness. Anyway, yeah, let's just go back to... There we go, there's the thread. Here's my bracket. So, Allosaurus and Ceratosaurus. I have Allosaurus beating Ceratosaurus. Interesting, I had Barosaurus beating Torosaurus. So, my bracket is no longer perfect. But Nodosaurus also beat Ornithomimus. So I was wrong there too. Interesting. Yeah, this East Coast conference over here. East Coast and Cretaceous and Miscellaneous Conference, I called it there. Yeah. Yeah. We'll see. Dryosaurus still does still have a chance to win the whole thing. I know I put that in jokingly. I don't think it's going to happen, but we'll see. Anywho, with that said, it's time for me to wrap up this stream. I've been streaming for 40+ minutes longer than I thought I was going to today. So, let's go ahead and commence our wrap-up procedure here. Put a Deinonychus skull under our credits. There we go. Thank you to everybody who's being named in our credits right now. We're going to find somebody else to raid into real quick. Somebody else doing some science on Twitch, hopefully. And Rhacodactylus is on right now. We'll go check out what he's doing. There we go. Yeah, good stuff. Thank you to the new followers, the subscribers, and the resubscribers, the cheerers, the gifters, the moderators, the raiders, the lurkers, the question askers, the enthusers. Hope you had fun today. Marsh Madness was real nail biters this stream. I'm pleased with how that's gone. Anyway, everybody, you all take care of yourselves. I'll be streaming the final stream of this week is tomorrow, Thursday, Birds Day. We'll be having some more Marsh Madness matchups as well. And maybe we'll even have some fossil news. We'll see if anything new comes out. Anyway, appreciate all of you. Let's go check out Rhacodactylus, cognitive scientist, and Twitch stream. See what he's up to. Take care, everybody.